Hello everyone. Uh, we are going to we are going to create a game using the Godot engine, um, and to get started, we are going to install Godot. So I'm using Google Chrome here, so you can use any browser of your choice. Basically, sign escape. Okay, so to get to Godot, so go to godot.org. Yeah. Okay. I'll search for Godot. Okay, sorry. Godotengine.org. Some silly mix up. Yeah, basically. So, click on download latest. If you want to download the previous version, you can click on Godot 3 here to download Godot 3. But we are going to use Godot 4 in this tutorial. Basically, if you are using 4.0 plus, it should work privately for the tutorial. But if I'll recommend you download the latest, which is 4.4. So click on it. Godot has different version. The like this one, the Godot engine 4.4. This version supports the built-in scripting language, which is GDScript. But if you want to use C sharp or other language, I don't know, but C sharp, if you want to get a C sharp support, you can download this version. Yeah, but we are going to go ahead and click on this. Like, we are going to be using the GDScript version here. So the wait for download is a very small file size compared to like maybe Unity or Unreal Engine. Is very lightweight. Yeah, it's very lightweight and a very powerful engine. So while we wait, let's show some features of the site. You can visit the docs over here if you want to, like, if you want to learn more about the Godot engine. This is the official the official documentation. You can get it all from here. So, like, this has a lot of helpful resources, and I greatly recommend visiting the docs from time to time, because creating a game is a very it's very difficult. It's not that difficult, but it's fun. But sometimes, or most of the times, you are going to run into issues. So the documentation is your friend. Okay, so let's wait for some minutes. Okay, while we wait, sorry, while we wait, I also want to recommend we download LibreSprite. Like, in this tutorial, we are going to be creating everything from scratch: the art, the game, the audio, the everything we are going to be creating from scratch. So we are going to be using LibreSprite to create our assets for the tutorial. So you can go ahead and click on download over here. Okay, there is an issue with my internet connectivity. So okay, so I'm using Windows for this tutorial, but if you are using maybe Linux or Mac, or you want to get the source code, I don't know, maybe are you a programmer, or you just need the source code for maybe experimenting with it. So you can download the source code here. But I'm going to click on the Windows if you are using Linux, okay, or Mac. we have the system requirement here, which is very very easy and very readable, very easy to understood. So let's click on download. So okay, this is the library sprite GitHub page. So you can just click what we are going to download, which is this one, the Windows zip file. If you are using Mac, you can click the Mac zip file. If you are using Linux, and if you are using Android, you can click here. Okay. Okay, and for the music, oh, we are not going to actually dive into music because we are going to use open game mat for that. We are going to get our sound from open game mat. Okay, let's just open it. We'll come back to it later. But for the SFX, let's click on HIO. Let's click on this. And we are going to search for, I think, yeah, it should be chip tone. Chip, yeah, chip tone. So we are going to hit the download button. All of these are completely free, so you don't have to pay, although you can pay to support the developers, which I recommend, but it's not compulsory. Like, all these are not paid software. So the Godot engine is completely free open source game engine for creating games and apps, obviously, but it's solely created for making games, not for apps. So which we'll be making in this tutorial. And OpenGameArt is a website that offers some free assets that you can use in your games, although they are completely, they are to be used based on their license. For example, let's say I want to use this sand castle stage. So let's click here. Let's check the license of the sand. So it's 600, which means we can use it however we like. It's completely free. If you like, we can credit them, but it's not compulsory. For 600 license, it's not that compulsory. So we got everything that we need. Let's go back. Let's visit the docs over here. And well, we've downloaded three different files for now. So we are going to visit our folders to extract them. So library sprites, let's wait for some minutes. But while we wait, we can also extract the rest, the chip tone extract. and the Godot engine. Okay, seriously, I just remember something. The Godot engine actually has a weird pronunciation. So let me show you something. Godot. Let's see how we should actually pronounce the engine. Like, I've been using Godot since since we started the tutorial, but it's actually not pronounced like that. So
Godot, 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 Godot.
there you go. It's very fun actually. So just a heads up. So let's close all of this. And uh I don't know, for those that are using, I don't know, maybe Mac, but if you are using Windows, you can easily send all these. Like, you look for the application file, this file for Chipton, click on it, right click, then click on send to over here, and click on desktop to create a desktop shortcut. So let's click on Godot also. For Godot, we are going to be using we are going to be sending either of these. You can run, or you can use the console application file, but you can also use the Godot application file directly. So we are going to send it to desktop also, and the same thing for LibreSprite. So there we have the LibreSprite. Let's click on it, send it to the desktop. Now if we close this, we should access all of this from the desktop. So this is LibreSprite, this is Godot, and this is Chipton. So first of all, let's explain what this applications actually does and why we need them for our game development journey. So LibreSprite we use to make pixel art assets. Pixel art is just placing. Okay, seriously, let's go ahead and launch the LibreSprite. I'll explain direct. So let's expand it. We can create new file from here. Okay, click on new file, 32 by 32. Yeah, and to explain pixel art better, let's show the pixel grid. Pixel art is just where a drawing where everything you see on the drawing are placed pixel by pixel. So this is one pixel, this is another pixel, this is another pixel, this is another pixel. So that's how we create the drawing, basically, by placing all these pixels all together like this. Although there are tools that we can use for the placement of this pixel. That, for example, this is a line tool, but we explain LibreSprite later on. But just know that pixel is just a drawing whereby that we made by placing color on a grid of pixel, basically. So you can change the color here, over here. So basically this is pixel art. Basically, let's just exit it. The Godot engine we are going to use for the creation of the game, so let's leave it at that. Chiptone we are going to use for SFX. SFX is like the sound effects in games. Basically we won't be explaining much about this area, but they are already pre-configured editor sounds that we can just use. All these are like, for this generator dock over here, we can see that all these, if you click on coin, we get a randomly generated coin sound. If we click on sap, same. For boom, same. For jump, same. And the list goes on like that. But we can also create it ourselves over, like, if you like. But basically, that's it for chiptone for the sound effects. So let's go ahead and start our game journey. I'll meet you in the next session. Okay, welcome back. So, and we are going to, in this part of the tutorial, we are going to actually get started in creating the game. So first of all, we've already talked about these three, okay, maybe two. We've already talked about the chiptone and we've talked about the Libre sprite. So right now we can right click the Godot icon and click open over here, but you can also double click it directly. So go ahead, double click to launch Godot. Obviously. So this I don't know, maybe we're complete that we this UI that we are looking at is the Godot project manager. So from here we can create a new project directly if you like. We can import an existing project if we have an existing project, because if we don't have any existing project we can't import anything. Or we can just visit this this is like, let's just call it like a sub window or inside the Godot engine, the Godot UI. So if we click on the project, we get uh, a interface where we can create, import, etc. We can also, like, if we have existing projects, this is where we can easily edit them or run them or even delete them and so on. But in the asset library we can actually download uh, projects created by the community, the Godot community. So let's click go online. We can download all these are known as templates. We actually want to change the category here to suit our liking. If you like, you can click on templates if you want a template. There you go. There are a lot of projects here that are very 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 helpful, but we're actually going to be creating everything from scratch. So crap. Okay, I don't know what is going on. Maybe let's just wait for a minute. Okay. I have a very very huge software running in the background. Maybe that's why. Well, my very very old computer can't handle that many stuff. Most importantly, since this is using online, so there is a lot going on in here. But we're actually going to get started and create our project. So this game, the game that we are going to be creating is, let's first change this version control metadata to none. So it's actually like, it's not exactly a space game, but it's very very related to like a space. So there'll be like a ship, and we'll be firing all other ships. So there is a pickups. We can pick a bullet. We can pick health, like that will be on the screen. So it's going to be like a top down game. So let's pick a good name for our game. um you actually want to turn on this toggle to create a separate folder for the game. Like, you don't want the folder to be mixing the file of our new game to be mixing with other files on your computer. So let's go ahead. Let me think of a game. Okay, let's just call it the defender. So basically it's not exactly a good name, but okay. Oh, sorry. Click on documents. Let's select this document folder. So the defender is already created for us automatically. If you get any errors, you can create a separate folder for your Godot project, but I prefer it on the document folder. So let's go ahead and click on create button, and Godot is going to switch from the project manager to the main Godot editor. So where we actually edit our projects and the likes. So well. To actually explain things better, we have to learn about how 3D works, how 3D and 2D works in general. So let's close the Godot. Let's open Libre Sprite now, 32 by 32. So we are going to use this to explain uh, how the 3D and 2D works. So let's say in basically our math class, we've learned about all these. We've learned about the Cartesian plane, stuff like that. Well, to learn about 2D also, we are going to be using this. So this will be our positive y, and this will be our negative y, basically. So this is 2 dimension. So for 2D, we basically will be working in 2 dimension. So this is a 2D plane. We can place, I don't know, maybe let's just say a circle. We can place a circle here at this location. So this is in the location of positive x and the positive y. So this is actually different from how the Godot works. Like, this is for the Cartesian plane, but we are just using this for demonstration purpose. So we can place any object on our screen, but that object must have like a location. We can also call it a position if you like, a rotation, scaling, etc. We are going to learn about all this transformation later in the course, but 3D works a little bit differently. So let's say that this is 3D. Right now, instead of having just an x and y, we also have a z axis. We also have a z axis over here also. So basically, we are dealing with three different coordinates here. Now we have the x, we have the y, then we also have the z. So basically 3D is a little bit complex than 2D. So we are going to, in this tutorial, we are going to be working in 2D actually. So the Godot engine works like this basically. Okay, this is just for demonstration purpose basically. So our origin is actually here. Our zero is here. Then we have the positive y over here. And then we have the negative, sorry, mix up, didn't know what I was thinking. We have the positive x over here. Let's just call this x. Please note, I'm just demonstrating here. You don't have to follow any of this for now. So this is our positive x, and this is our positive y. So our x-axis progresses just as the Cartesian plane, but for our y-axis it's a little bit different. Instead of the y progressing upward like this, we have it progressing down like this basically. But in Cartesian, we have our y progressing upward like this. So basically that's the difference between how we are taught simple graphs in school and how Godot actually works. So let's go back to the Godot engine, and to switch between the 3D space that we have over here to 2D space, just click on the 2D button over here. Don't forget, like I called this sub window before. So basically we have the 2D, let you work in the 2D space. We can use it to create 2D games, but we can also use it while working in 3D. Maybe you want to create like HUD, as heads up display or something like that, or the UI basically. So we also have the 3D space that we can use to work with on the 3D stuffs. We also have the script. This is where we this is where we're writing our codes, the GDScript language, using the GDScript. So we can also, like, this is a new feature. So if you are using Godot 4.0 plus 4.0, 4.1, 4.2 and 3, you are not going to be using You're not going to be seeing this button over here. Well, but this is a new feature that is added to the 4.4 function. So you can also click on the asset library. This is just like the one we saw earlier in the menu. So but now we have more categories, which is different from what we saw in the menu. So let's go back to our 2D space, and to better demonstrate what I showed you in Libre Sprite, okay, right, this is, let's click on this is location 6. We are basically looking at a vector. Just think as vector as what is more than one information. Like if we have basically more than one information, like a number that we have here, we have 6, then we also have 6, we have 2 6. We are looking at a vector. It can be 3 numbers, it can be 4, but if it's more than one, we are basically looking at a vector. That's the basic definition of a vector. So the 6 and 6, we are looking at another. What I'm checking, what I want to show you here is how the y progresses downward. So the 31 that we are looking here is for the x-axis, and the 25 is for the y-axis. But as we go down, the UI over here, basically our editor here, our 2D space, so we are going to see that our y progresses. It increases instead of decreasing as the Cartesian plane. This is a little bit different. So, and it decreases as we move upward. Basically our x increases as we move to the right, and decreases as we move to the left, basically over here. So that's the basics of this. So how does Godot actually work? So I'm actually going to start explaining. We are going to start explaining all these stuff. So this where my arrow is, or cursor basically, is a dock. This is a dock. This place is a dock. We can expand this dock. This is also another dock over here. There is also another dock over here. So what does these docks do? Well, first of all, we can visually see that the docks makes visually sense of everything, the position of everything. It helps it to be like more organized. So over here we can, this is for the scene dock, and this is for the view ports or the view dock. So this is basically where we'll be creating where we'll be editing the position of our game objects. And this is for the properties dock, but it's basically more than that, because we have the inspector button over here, we have the node, then we have the history. Basically over here also we have the scene, we have the imports. I'll go over this in maybe future tutorials. We also have the file system dock over here. So basically, okay, let's go under the under documents. So this is our file folder. The file system over here is synonymous to the file folder. The rest folder here just signifies that this is our root folder. So we can create new folder. Let's go ahead and create new folder. Let's call this scenes basically. And if you go over here, we've seen that our new folder that we created here is already here, which is our scenes. Let's go ahead and delete it over here. And if we go over here again, our scenes is no longer more because we've already deleted it in the file system. So how does Godot work? Let's go back to LibreSprite. Godot works by using something called nodes. So nodes, actually, let's think of them as what provides us like basic functionality, or although we can extend their functionality, but we actually create node to be used for a certain purpose. For example, if you want to create or a player, or we want to display an image on the screen, we are going to be using nodes for that. But if we have two or more nodes group inside there, like if you wanted to group a list of nodes, we are going to be grouping it on in a scene. A group of nodes is known as a scene. We can have basically one nodes in a scene, but we can have as many as we want in a scene. So that's basically how Godot's engine works. Let's go back to the Godot, and we can start creating our root node. Basically, if you are familiar with a tree, this will be familiar. Like, we have a root, then we have a child over here, we have the grandchild, and so on like that. But let's get started and create our root node directly. So we can click this plus icon, or we can press Ctrl A to display this create new node window, or we can click on the other node to create our new node. So what we actually want to look for is a node. Yeah, we want to create, we want our root node to be a node. So we are going to double click it. We can see a basic description of the nodes over here, of the node over here. So if you can read it if you want, but I'm going to be explaining things as we move on, as we progress this tutorial. So we've created a new node. Our new node is called node, but we can rename it however we want. Renaming a node doesn't change anything. Like, what we need is the functionality this node provides. We can already saw that in the type. We can change the type directly. For example, let's say we don't want a node type anymore. We want, let's say, a sprite 2D. We can easily change it over here to a sprite 2D. So I'm just going to click cancel over here. To rename a node, we can right click it, click on rename, but you can already see the visual helper that says that we can already click F2 instead of right clicking and clicking rename. You can just click F2 to rename our nodes. But we can also rename our node by double clicking the node and changing it to something else. Let's name it our root. So there we have it, a node that basically does nothing. A node is basically a node. It's mostly used for grouping stuffs. Like if we have other nodes, we want to group it. Let's say we have Like enemies, we want to group them under a parent so that we can easily find all our enemies in a single location. Gosh. So that's what the node is used for. So we also have other nodes that are used for different things. So we are actually going to start introducing nodes for now. So let's go ahead and we can click the plus button here. You can call it an icon, you can call it a button. So let's click it. You can also click the control A as discussed earlier. So to display a 2D image, we are going to be using the sprite 2D node. So we can easily go over the description here. It says a node that displays a 2D texture. The texture display can be a region from a larger atlas texture or a frame from a sprite sheet animation. So basically, just know that if you want to display any image on our screen, we are going to be using a sprite 2D node. But we can also use the animated sprite 2D node or other nodes that also perform displaying an image on the screen. But as discussed earlier, each node gives a different functionality. So for displaying just the image on our 2D view, we are going to be using the sprite 2D node. So let's click ahead. Let's click on create. So we are looking at this point over here. Let's click it again. So this point over here is our origin point, which is 0 0. Don't forget that it progresses downward. So our y goes down like this, our x increases like this. So to display any image on our UI, we've already added a sprite 2D node as the child of our root node, but we are not seeing anything. Why is that? We actually want to see an image. So let's go over the properties, the inspector tab over here. Sorry. So we are looking at the texture property. If you hover over the texture property over here, we see that we need to provide a texture 2D object to draw. Okay, to actually see an image in our 2D scene over here, we are going to drag this icon.svg file. We are going to drag it into the texture property over here. Then let's go, and now we can actually see our texture. So let's say we have other texture for over here. We can easily just drag it to our texture property over here to change the texture. So I think now is the right time to leave the Godot editor and actually go ahead and make our sprites. So let's click on file, new file. So if you actually want to make the sprite, you can follow along. If not, you can just skip ahead in the tutorial. but I would actually recommend following along. You can use other pixel art software like graphics Gale or graph fx2 or something like that. We also have Aceprite. Aceprite is actually LibreSprite is actually created from Aceprite. So if you are looking for the software that I would recommend the most is actually Aceprite. But Aceprite is not completely free. The source code is released for free, but the application file is not free. So it's actually very cheap. It's worth the money, but for this tutorial I want everything to be free so you can follow along without paying anything. So let's go ahead. Let's make sure the width is 32, the height is also 32. Let's click on this. We want our background to be transparent, our color mode to be RGBA. RGBA just stands for the red, green, blue and the alpha components, so that we can include transparency in our assets. So go ahead and click OK. And we are placed with we are given a canvas. So this is actually what we can draw on, basically like that. But this is not how pixel art works. So first of all, I'm going to assume that you have by the way, if you want to do what I just did right now, like if you want to just move stuff away from the screen, just go over here, click on this rectangular marquee tool. If you hold it, you can see that we have more than one option here, but we are going to be using the rectangular. We're not going to be using the circle and the likes, but we are going to be using the rectangle. So you can just use it to just drag a portion of our sprite and just move it away. Portion of our drawing rather. You can just move it away like that. If you want to actually draw, we are going to be using this pencil tool over here. The shortcut for it already we've been shown is B. So let's go over here again. We also have the shortcut for the rectangular marquee tool, which is M. We have for the pencil, you can over this all these two. This is a toolbar, so we have the tools over here. I would actually recommend visiting all these tools, but yeah, for now we are going to be using the pencil tool. So we can change the our pencil size over here. If you want a larger pencil, so let's say like 8 pixel, and we can start our drawing. But you don't actually want that in pixel art, so we're actually going to stick with the 1 pixel. So let's move this aside. So basically there are steps to creating pixel art, but my most recommended step is to start with the silhouette. From there we can refine the shape as to our liking. So let's go ahead and do just that. Okay, so we can change our pencil color over here. For now it's black, but if it's different in yours, you can just go over here and click over here. when we right click, we are using uh if you right click and drag, we are using we have the front color, then we have the under color. So we can change the color for the right click by just right clicking any of this color. So this is a color palette. I think we are basically not going to be using this palette a lot, so we are really not going to be using it. We may use it, but at the same time we may not use it. What we actually needed is to go over here, click this icon over here. To change the color, you can move over here. You can change the hue over here. You can change the value and the saturation over here. But we are not actually going to be using this color picker. So let's click over here. We are going to pin this new window, because if you let it go like this, it disappeared. But we actually want to leave it open, because this is actually how we are going to be picking our colors. So let's click this icon over here and let's drag it over here, I think. Yeah, and let's clean our canvas. So to get started, we are really going to be using basic shapes, because this is not a pixel art tutorial. I'm just showing you how we can create everything from scratch. So hold the rectangle tool over here, right click left click and hold, and let's move over this circle but not filled. This is rectangle but filled, rectangle but not filled. This is circle but filled. So we are going to click this circled but not filled. So we can just go ahead and start drawing our circle. But first, we are going to click this horizontal symmetry button, so that whatever we are doing here, we are also doing over here. So let's just draw some basic shapes over here, and it doesn't have to be perfect actually. So this is just a silhouette, and we'll make some refinements later. But for now, let's just draw. I'm just drawing circle all around, basically to get this shape. And okay, so this is the shape that I got. You might got a different shape, but let's just start cleaning up the pixels. So I'm going to switch to pencil to make some refinements. So this will be like the mouth or something like that. Yeah, I think that looks cool. And in pixel art, we actually don't want stuff to be 2 pixel wide. I actually want it to be just 1 pixel. You can see exactly what I'm doing. Just 1 pixel, 1 pixel, 1 pixel, 1 pixel, 1 pixel. You don't want like a lot of pixels in our drawings. Just want a few pixels. Basically, I think I've already picked the color for the skin. Basically, first of all, I'm going to change the outline to a dark blue, a very very dark but blue. The reason why we are using a dark blue is because we want it to be friendly, to be relaxing. So we don't want to go all the way black, but at the same time we want it to look like it was a black outline. If you like, you might not even use any outline at all. So what I'm doing here, basically, let me stop for a minute, let me pause for a minute. What I'm doing here is I'm using the field tool. The field tool should be here, the paint bucket tool, but it's called a field tool in some other software. So what I did was actually use the shortcut button, which is G. So you can go ahead and click G on your keyboard with this HSB color over here. You can just go ahead and paste it if you like, but at the same time you can pick other colors that suit your liking. If you are looking for a more sharp color, you can go over to the red, increase the saturation to get a more red color, but we are not going to use that for now. So to pick the color I'm using before, I'll just click on the I button on your keyboard, then place your mouse over the color you want to pick over here. So this is a color picker. What we did right now is just use the color picker to pick a color. So right now I'm looking at the image, I'm looking for faces, what I can fix, and I think I already found one. We are going to change our selection to circle select because I want to select this eye over here and move it a bit. But as you can see, as I move it, it moves symmetrically, which we don't want. So let me just cancel this symmetric button over here, and let's move it down a bit. I think like this, basically. And we are going to do the same thing for over here. Sorry. So don't worry if your drawings are not exactly like this. I'm not I'm not a perfect idiot, so you might even get a better drawing than this. So basically just keep making some little fixes to the drawing by using the tools we've already discussed: the the color picker over here, the pencil tool, the B for placing the pixels, etc. So let me just go ahead and keep placing pixels. You can actually see over here that I'm using doubles. Like there's a 1 pixel over here, there's another here, which is completely fine, by the way, because this is not just a line. We are going towards like a 2D 2.5D shape, but it's also a 2D, but we want to make it more like a 3D, so that's why we are using that. So let's go ahead and create the eye over here. Okay, that doesn't look too well. So pixel art is basically like it's like you are placing a brick. Like if you don't like things, you can remove them. If you like it, you can easily change the shape for some little fixing. So you can think of it like I think the best way to think of it like maybe sculpting. If you are used to sculpting, basically, I think. So let's go ahead and with our outline. This is not a must. If you like, don't use an outline at all, but I prefer outlines, so let's just go ahead. So this is our character, our player leg. So let's do some fine adjustment over here. Don't forget, the reason why we are not doing this like this is because we don't want all this. It's known as jags in pixel art. If you want to create a curve, you should create them like this. You shouldn't create them like this. Like, we want a smooth curve, even though this using the curve like this might make sense, but it doesn't really look that nice visually. So what we want is to avoid jaggis at all costs. But if you look at my drawings, you can already see that I avoid jaggis at all costs. But yeah, we have another jaggis over here, which is completely fine, by the way, because I actually want it to be here to give like the eyeball, so that player can know that, okay, that's the guy's eye. Okay, basically. So let's go ahead and delete this. Okay, so I believe we complete the guy's silhouette and the shape, the basic shape. So next we are going to do some simple shading. So first of all, let's go with a skin color. I've already used one here which I don't like anymore. I don't like it anymore. So let's go with this. Let's decrease the brightness. This the H over here stands for the hue, the S stands for the saturation, and the B stands for the brightness. We also have the A, which is basically how is opacity, basically, or alpha channel. If you are used to working with alpha, you can also use the RGB color picker, but I prefer HSB, and most artists also do. So let's stick with the HSB. So let's decrease the brightness a bit. We're actually looking for a base skin color. I want this guy to be a little bit fair, not too dark and not too white. So this is our base color. So right now we are going to pick a dark color that we are going to use for the shading when the time comes. So we don't want just one skin color. For the darker area of our character, we want to use a less bright color. Let's increase the saturation a bit, but let's decrease the brightness. And we also want it to be less vibrant. So we are going to move the hue from, if you look very well, this is around the middle of like red and yellow. So we are going to move this towards red a little bit. If it's for the lighter part of our character, I'm going to move it towards yellow, but it's for the darker part, so let's move it a bit to the red. Okay, I think that's maybe a little more bit. Yeah, and the brightness, let's decrease this a bit, a bit, a bit. Okay, okay, I think that looks okay. Right now we also want a lighter part. Like, we've got our base color, we've got the shadow, the dark part. We also want the light. So what we are going to do about this, we are going to decrease the saturation. If you like, you can increase the saturation, but most importantly, we want to increase the brightness. I want to move our hue towards yellow. Okay, okay, we're going to click to add the color to our template. So let's go ahead and start shading. I'll click the G button to fill. Okay, there you go. You want this area to be a little bit dark, so let's go with the dark color. You want this place to be, all this left to be dark, dark. Okay, and let's give it a cloth. So he's wearing some green clothes. That looks fine. Let's give it some eye. I'll go over I'll pick the white color over here. Go over the alpha channel, decrease it to around like 128 basically, and let's just keep filling it to high. Okay, but this is not done yet. Basically, you actually want a lot of fixing. You have a lot of fixing to do. For example, this green. Let's go and pick a little bit more dark colors over here. I just place it in here. Place it in here. Just place it around. So create a little bit like a 2.5D look. So the light is coming from top. We still want more light color over here. Let's increase the brightness. So there's a lot that goes into colors actually, so just keep experimenting, and I think we are okay right now. Yeah, this is amazing. For this tutorial, we are not going to be using um, animation, but I actually want to show you some basic animation to get started basically. So let's open the timeline tab. Go ahead, click the view on this menu bar over here, then click the timeline. You can also click the tab. We've already been shown the shortcut key over here, the tab button. So let me go ahead. So let's click on this. You can rename your layer if you want, but we are not going to dive into all this stuff for now. Let's go ahead, right click this, our first layer over here, and click on new. So what this does is actually it duplicate the layer. So we want a very basic animation that it just what we are going to do is like we are going to change the height of our character over here, so that it goes down a little bit and moves up, goes down, moves up, like, and make it seem like it's alive. So the basic way to do this is just chisel away some pixels over here. You can also, after After selecting the pixels, you can easily click the delete button to delete it automatically if you don't want to be moving things around. So let's select everything from here, let's drag it down, and now we have an animation to play. Let's go ahead and click the play button. This, sorry, the shortcut is enter. So let's go ahead, and we have a very basic animation. So there you go, a very simple animation for our character. So if what you get at this point is not this, it's completely fine. In fact, you don't have to make a complex image. In fact, this is not so complex, and the reason why I choose this is because we are not diving into the details about how to draw stuffs. So this looks like a time, I don't know, but basically this is our character. This is our main guy that is going to be like defending stuffs like that. So there you go. To make this tutorial a little bit more simple, what we are going to do is like, we are not going to create completely new character from scratch. What we are going to do is we are going to just change the colors of the characters. So you can go ahead and choose different color from for different enemies. So we will explain how we can use all those enemies later in the tutorial, but this is a very very basic tutorial, and just changing the color should be okay. But if you like, you can go ahead, create new characters, and basically that's fine if that's fine with you. But to avoid over complicating things, let's just stick with this for now. So to export this our character over here, let's click on file, export. But no, we don't want this. We don't actually want this at all. So what we want is that we want to export the sprite sheet, because now we have an animation. We don't want to just export like a single frame out of the animation. We want to export both the frame, like this is frame 1 and this is frame 2. So to do that, click on file, export sprite sheet. You can add some padding over here. You can change from the sheet type from horizontal strip to vertical, or by rows and columns, but let's just go with the horizontal strip. No padding will be added. Visible layer, yes, you want the layer 1 which is visible. All frames, yes. So we are going to click on export, but first of all, what is going on? I cannot do export. Okay, basically I don't know why it's displaying this, but this is a little bit different from the version I'm using before. So you can actually see that we need this output file to be open over here. So we can rename our file, you can change the type over here, but we are going to stick with png because png supports transparency, and we need our some part of our image to be transparent so that we can use it in the Godot engine. Okay, sorry, Godot engine. So this is the folder we created earlier, the defender folder. So double click it. We are going to create a new folder over here to keep things organized. We are going to call it assets. Under assets, we are going to click on the we are going to create a new folder called the img. You can name it images, but I prefer img. Img is just images for short. So we are going to name this player.png, and let's go ahead and click export. So let's go over the document, the defender, the assets, image, and there you go. We have our image over here, the character. So let's just go ahead and change the color however we like. Let's change it to blue. Don't forget how we actually normally do things. You want the base color, you want the dark color over here, and we want the light color. It may be too light. So same step, obviously. So we want a visual difference uh, from the player and the enemies. So these are all enemies. Now, okay, good. There's actually a better way to change all these colors, but I won't be using that in this tutorial. So wait a minute. Okay, there we go. Let's export this enemy one, our very first enemy. That's PNG. Well, for now we are going to leave it at this. If you like, you can create more variation of this. You can change the pixels, just experiment. Seriously, this is very fun thing to do. Just keep drawing, keep drawing, keep drawing, keep drawing, keep drawing. You might even come up with a very, very, very great art. So pixel art is very, very easy. So that's why I stick with it in this tutorial and not, vector art. Vector art is also easy, but just placing pixels is not that difficult to grasp. Yeah. So that's it for the asset part, and I'll see it in the next part, obviously. So then. Okay, and welcome back to the tutorial. So uh we've got our new asset folder over here. We've got our enemy one, we have got our player. You can easily preview it over here. Nice. So actually, let's start creating our player. So let's just go ahead and cancel this. So to create our player, we want our area to the node. Basically, one of the reasons we are using this area 2D node is uh, we don't want uh, like physics in our game. Like the main idea of the game is like just move around, shoot people. The people will be coming. Don't shoot the enemies. Sorry, the enemies will be coming towards you, and you have to like shoot them basically. And so the idea is like if you and the enemy collides, your health reduce. So you basically you have to avoid the enemies. You can shoot them, but at the same time do not touch them. So that's how we want the game to go. So but if you want, if you actually want the player to collide with the enemy, we are not going to be using the area 2D. We are going to be using like maybe the character body 2D node. But for this tutorial we are going to be using the area 2D node as the root of our player. So let's go ahead, it create, hit F2, rename it. Let's name it player and nothing. Create our player, yet we still see nothing in our 2D space. So what are you going to do right now is, first of all, we are going to save. You can click the scene button over here and click the save scene, or you can click we've already been shown just like the libre sprite. The shortcut for the save scene is Control S. So let's go ahead and hit Control S. So our how Godot save a scene file is using the .tscn file format. But instead of hitting save directly, we are going to create another new folder. Like what you actually want for your game is to keep things as highly organized as possible. So for now, let's go ahead and rename this new folder scenes. So this is where we are going to put all the scenes in our project. This is where we are going to save them. So let's go ahead and hit save, and now we have a scene over here. A little bit of an aesthetic stuff is you can actually set a color for each folder. So I'm not a fan of this this feature, but some people prefer it. If you like, oh, different color, oh, I've got this color for my scenes folder, I've got this color for my assets folder, I've got this color for my scripts, and so on like that. So you can easily change the color by going over, by right clicking, choose the set folder color and click any of the color over here. So I'm not a fan of this, as I've said earlier, basically. So we've got our player, but nothing. Don't forget what I said earlier, that if we actually want to just display an image on our 2D space, we are going to use the sprite 2D node. But actually right now we are going to do something a little bit different. We are not going to be adding a sprite 2D node. We can use the sprite 2D node for the functionality that we need, but for simplicity of this tutorial we are going to be using animated sprite 2D node. Let's go ahead and add it. This is animated sprite 2D. So basically we are seeing a lot of warnings over here. First, the root has a warning which is this node has no shape, so it can collide or interact with other objects. Consider adding a collision shape 2D or collision polygon 2D as a child to define its shape. We'll come back to this later, but let's fix the warning for animated sprite 2D first. A sprite frame resource must be created or set in the sprite frames property in order for animated sprite 2D to display frames. So what this means is that we've added our node as the child of player, but it's not just going to display a sprite on the 2D screen. We have to we have to configure all the animations. That's why I'm not using the sprite 2D, because for animated sprite 2D we can add as many animations as we want more easily, compared with sprite 2D, which is basically just to display image on our 2D space. So let's click the animated sprite 2D, go over here, click on the animation. On that sprite frame we want to create a new sprite frame, click on new. So we are given this new dock, obviously. So what we actually want to do is to add a new animation. You can use this button over here to duplicate, to delete, and to autoplay an animation. You can use this autoplay unload. You actually want to leave this on so that our animation is going to loop. Don't forget that we have an animation for our player already, the breathing animation, where the player goes up, goes down, goes up, goes down. So let's go ahead and rename, okay, sorry, go ahead and rename this from default to I do. So and we are going to create a new animation. We've already created the animation here, but no images at all. So if you actually have not a sprite sheet but single image, like player 1, player 2, you can just drag it over here. But we don't want it to look like this. We don't want this. We want one frame at one time. Sorry. So we are going to delete that. So this is for the animations, and this is from the frames. You can see over here, this is animation, this is animation frames. So if we delete this, we are going to delete this I do, but if we delete this, we are going to be deleting our animation frame. So to add the player animation, click on this add frames. So let's navigate to the folder for our player. If you look at our player very well, you can see that there are two frames for it, in the vertical, in the horizontal, sorry, and the vertical we have just one. And good, let's click on this. This is our first frame and this is our second frame. Let's add it, and now we can easily play our animation. And there you go. This is a little bit slow actually, so we can change the animation speed over here to like maybe 8. Okay, that looks so cool. Because this is pixel art, you can see how the engine tries to blur our image, which we don't want. We want it to look like this. We don't want it to look like all this blurry stuff. We don't want anything. We don't want it to be blurry. We want it to be blocky. So to do that, let's just click on the project setting, and let's go under rendering over here. Just click on the texture. You have this canvas texture. We have the default texture filter. Let's change it from the linear to nearest, and we can easily close it, and there you go, fixed. And we have our player. Okay, so you can already see that now we don't have the warning that we got earlier. To make a node visible or not, you can easily click on this icon. Also, if you notice very well, if I click on this icon, we are getting a notification here that we have a one change. So if you go over it, you can see that this actually changes the visible over here. So this is like a yes or no. Do you want it to be visible? Yes. Not visible? Yes. And basically that's it about it. So we can, there are a lot of different properties over here that we go over into in later, maybe later courses, but for now let's just leave it at this. So let's go over the second one that says about the shape. So everything in our scene that basically we actually want to be able to detect, because this is our player, want to detect when maybe other nodes enter it or are overlapping with it, like the player. Like we want we want it so that when the enemies are colliding with the player, we are getting a a guide that shows that the enemy is now colliding with the player. But the engine wants like a collision shape so that it will know that okay, this is the area that the player is. So basically that's what an area 2D is. It must have a collision shape. It's not even compulsory that it has an animated sprite 2D node, but it's very compulsory that it has a collision shape 2D. So let's go ahead and add it. Let's search for collision shape 2D, and we are getting yet another one. A shape must be provided for collision 2D collision shape 2D to function. Please create a shape resource for it. So to create a shape, you can already see over here we have this shape, create new, and these are the uh, pre-configured shape. If we actually want to like create our shape from scratch, we can also do it, but let's just go with the circle shape because our sprite resembles a circle the most. Let's just make it a little bit small like that. The reason why this is small and not big is because you actually want your game to be friendly. You don't want it to be that hard or difficult for players. You want players to be like, no, the enemies shouldn't be able to shoot at me, but now the enemies are shooting at him because uh, the collision shape is just as big as this, which is not very cool. Even this is not cool. You want your game to be friendly. You want it to be forgiving, very very forgiving. So let's leave it at this and save. Ctrl S to play our scene, the player scene. This is a scene. Don't forget we've already discussed about this. Collection of nodes is a scene. So this is the root node. This is our child, a child of the player. This is also a child of the player. So collision shape 2D over here and animated sprite 2D, they are both siblings, if you can call them that. So this is basically some basics about trees. So I'll leave a link to more explanation on trees in the video description if you would like to check that out. So if you to play our scene, you can just click the play icon over here or click the F5 button, or you can play the current scene which actually we actually want to do, or we can easily click F6. And there you go. Okay, this isn't actually what we wanted, so why are we getting this? Actually, we don't want this to be like embedded game. We don't want it to be this to be toggled on. We want it to be like this or that. Also, we don't want it to be embedded on play. We don't want that, basically. So let's just click anywhere over here Let's pause the play and let's play again. And there you go. This is our game. Game. But let's notice something over here. We are not seeing the full uh, player. Why is that? Well, the reason is because this is where this camera start to see things. This is basically the origin of our 2D space. And let's zoom back a bit, and you can already see this tiny, I don't know if you can see it on, but if you are following along, you already saw the, like, a small rectangle on the 2D space. This is what we are actually going to see when we run our game. So basically that's why we are not seeing the full character. So for now, we've successfully created the basic structure of our character. So the next thing we are going to do is to add a script, because for now, when we want our character to move when we can click the arrow buttons, but now if I click the arrow button, I'm getting nothing. Let's go ahead, click on the player. You can easily click on the attach script over here. At the same time, you can click on this script button over here. So I want it to inherit from area 2D. We want the language to be Godot script, and let's choose a location to save our script file. So create a new folder, name script, and create. Okay, now we have a basic text editor, and we can easily edit our player file directly from here. If you are used to, like, maybe VS Code, you can easily use all this text editor stuff, but I won't recommend it because there are a lot of helpful features over here, like auto completion that I just got right now. So you are not going to get that when you are using external text editor. So let's go ahead and write code for our player. First of all, don't forget I made mention of vectors earlier. So what you actually want to do is, like, we want, when we press the left button, we want to deduct the player's S position so that it moves like this. When we press the right button, we want to increase the S position. When we press the Y button, we want to, like, the up button, we want to, like, decrease our Y position. And if we press the down button, we want to, like, we want to increase our Y position if you press the down button. So actually do that with ease, we are going to be using vectors, since the position of our character actually consists of two data. We have the X coordinate of our player, we also have the Y. So let's say that we are working in 3D spaces, we can also include the Z axis, but for now we are working with a 2D object. So let's go back. You can easily go back to the script and tab over here. So let's just click on script, and every time a node every time a node is visible on when we are running our game, when a node is visible on the screen or enters the tree of the root scene, the ready function gets called. So a function, let's just say, like, a function executes like performs an action. So a function is a little bit different from properties like the x and y position of our object is a little bit different. So function just executes whatever is in there. So it executes all the code in here. And I also want to like quickly explain something. If a function won't have anything to do, if it doesn't have any function, or you like maybe you add something to it later, you can easily add the pass code over here. You can easily just add the pass so that the Godot and the engine can easily recognize that this function has nothing to do. It executes nothing. It performs nothing. So, but we're actually going to do something over here. First of all, what you are going to do is like let's firstly delete all this function already. Let's start creating variables. To create variables, we use the var keyword. So var variable name to equal some value. So basically that's how we create a variable. First of all, we want the die variable. Die is just short for direction, and we want it to be a vector too. The reason why we are creating a direction is because we want to be adding something to the position, and we need a vector too, so that when we are moving up like this, let's say we press the up button, we want the vector y position to be positive, to be negative, and when we are moving down, we want the vector's y position to be positive. If you are moving left, left over here, we want the vectors x to be negative. When we are moving right, we want the vectors x to be positive. So that's why we have a direction, which is a vector. For performance sake, you can easily add the type over here by using the double colon and just pressing the type, which is vector 2. So first of all, we have to make some changes. This our game screen is a little bit too huge. We don't want that, so let's go over to the project setting. So we are going to go under the window. We can change the viewport width and the viewport height directly over here. We want it to be 640 times 320. And we want the stretch mode to be either canvas item or the viewport. I'll stick with the canvas item. We want this aspect to be keep. So basically that's everything about the project setting over here. So let's close it, and now we are going to use another inbuilt function just like ready, which is called every time a node is a scene is added to, like basically a node is added to the root of our scene, of the current scene that you are viewing. Basically enter, and ready just means that this node is currently active. But for the process is actually called 60 every 60 and 60 times per seconds. So in games there's actually this thing called a loop. So that's what the process function is. it gets called again and again and again and again and again. And actually that's exactly what we want, because we want to be constantly checking if the player presses the left button, the right button, up, down, so that we can perform actions based on what the player did. So to demonstrate this, first of all, we are going to change the position dot x. Don't forget the position is a vector, so we are getting our x value of the position and we are changing it. We are incrementing it by plus or this plus or minus just is the same thing as saying equal to something plus something, equal to position dot x plus something, but the shortcut for it is just plus or equal to. If you are not very good at JavaScript, I recommend watching a basic beginner tutorial. So we are going to be incrementing our x position with delta. This is just for example. So what is actually going to happen is that our player is going to move right. Okay, okay, actually our player is moving, although it is very 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 slow. Let's juice it things up a little bit, multiply by 6, that should be fine. And there we go, our player is finally moving. And now we don't want this. What you actually want is like, we want to check if if the player is pressing, if the person playing our game is pressing the arrow buttons. So if the player is pressing up, we want our direction, sorry, dot x to be positive. If the player is pressing up, we want our direction dot y to be negative. If he's pressing down, the down key, we want our direction dot y to be positive. If he's pressing the left key, we want our x direction dot x to be negative. If he's pressing right, we want this to be positive. So we can use the Godot built-in input system. Like we can easily check if it's pressing left, up or down, stuff like that. But what we actually want to do is we want to bind two keys together. So some player prefer using WASD, while some prefer using the arrow keys. So we want it so that we don't want to be calling if we don't want to be checking if the player is pressing W or if he's pressing the up arrow key. So we want to bind those keys together, which we can easily do with Godot engine. So let's go to project setting. Let's go under the input map, and this is where we can set our input. So let's go ahead, add a new action. Let's call this up, and ensure if you are using like Godot 4.0 to 4.3, the decimal over here is probably 0.5. You can easily reduce it to 0.2, or you can just click it over here and press the 0.2. 0.2 is way more better than the 0.5, but it's up to your choice. Obviously this is your game, and if you feel like 0.5 makes sense more than 0.2, just go with it. So to add an event, because we basically want it so that this up is bind to two keys, which is W and the arrow, the up arrow. Okay, so let's go ahead and add an event. So first of all, we want the up arrow key, then we also want the W. So you can just repeat the previous step. So we want the down action, Let's add it then. And that's it for our input mapping. And well, before we actually end things, we want it so that the player can shoot. We obviously want another button for that. So to shoot, um, let's just use like the X key for shooting, and let's close it. First of all, we need a constant variable. Constant variable are variable basically that you don't want to change. You can't even change their values. So let's just make the speed 100, because actually we don't want our player to be that slow, because we want it to be want our player to be a little bit fast. So using the by multiplying the position, the small increment that we are adding to the position by the speed, it will boost our player movement a bit, so that the player can move a little bit faster than it was before using ordinary the direction. So what we actually want to do now is to set our direction to equal to a built-in. If you are used to like classes basically can have methods, can have property, so the same analogy also applies to the Godot engine. So we have the input classes, the input class that have the get axis method or function, and now wait, we don't want the get axis, we want the get, I think it's get vector. Yeah, we want the get vector. So the get vector, what we are going to pass it in is that what it needs, first of all, what we move this negative x, the positive x, then we have the negative y, then we have the positive y. So let's go ahead and do just that. The name that we are going to put in here must match our input map that we defined earlier. So left, right, and there you go. Now we have a direction that basically is keeping the record of our input. And now what we actually want to do right now is to add the direction to our sorry, I'm thinking to our position, go to our direction, multiply by our speed, the factor, multiply by our data. The data just ensure that the movement is consistent across all devices. So let's go ahead and run our scene. And there you go, this is not very cool, although first of all, congratulations to us for making this basic player movement already. And this is very 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 great. So but it's still very slow, very very slow. So let's juice it up a bit, maybe 400. Okay, that's a little bit too much, but I think I like it. So we leave it at actually maybe like 250. And before we left, before we stop all this, we actually want to do something. We want to keep our previous position. Mhm. Why are we going to do that? Well, that's because we actually don't. We want like a smooth transition between the position, the new position, and the previous position. So to do that, just follow along, because what we're actually doing is we are making our previous position to be the next position. So our position is now going to change to that next position using the lap function. So lap function from position, this is where we want the smoothness, to the pref position. I don't think, I think let's call it next position, not pref. Next position. Yeah, next position. Okay, yeah, last argument, just add like maybe 0.5 for the weight. Don't want it to be that much. Okay, that is a little bit more smoother than if you are not using lap. Basically, okay, let's keep it at 300. Okay, well done. We've successfully created our player, and now we are going to create our new scene, which is, let's create the enemy first, because we actually needed to tie the game all together. So just like before, we are going to create a area 2D, rename it, oh sorry, enemy, save it, enemy.tsn, yes, and I'll meet you in the next section where we create the enemy scene. Hello and welcome back to the tutorial. So today we are going to decrease the enemy scene. So this is where we left the last tutorial. So let's click the enemy over here, and let's add animated sprite 2D as the child. just as we did for the player and the player scene. So let's go ahead, click the animation. Okay, let's rename it to I do. So this is our enemy sprite. So let's add it. Okay. Okay, now we've added the enemy sprite. Okay, let's add a collision shape to our enemy. So, but we are going to make the collision shape to be very small, maybe like that. Okay, that's okay, I think. So we finished the enemy scene. So let's save it. There is something I quickly want to call you guys attention to. So the previous code is something like um wait a minute, something like this, where we are using lapping, but I don't want to use lapping because lapping is using integer and I want to use a float. So that's why we'll be changing it to float. But now we get an error over here that says that lap f function, which is just f is for float, and think as float as a number with decimal and integer as number with no decimal points. So for example 0.5 is a float and 5 is an integer. So but our position is a vector, our next position is a vector, and lap float is expecting a float, not a vector. So we are going to pass it a vector. Okay, so we are going to do it one by one for the x position and sorry, for the x and for the y. Okay. Okay. Now let's test our player scene. Okay, everything should be working perfectly fine. Okay, but the reason why I'm using the float version of the lapping function is because um, we actually want a very nice smooth transition from the previous position to the next position. So that's why we are using lap f. So if lapping is okay with you, you can keep using it, but I prefer using the lap f function. So let's close it. Let's go back to our enemy scene. There are a few changes we'd like to make. First of all, let's create the main game scene. So if you are making a game and you just want a basic node with no functionality whatsoever, you are going to be using a node. Funny enough, is named the name of the node we are using will be named node for such functionality. So let's go ahead, add the root node. Let's name it our main. Let's name it main. Okay, So to add our player to the main scene, we're just going to drag it like this, and you can see that it is automatically added as the child of the main node. We can delete it. There are a few ways to add a child node that I want to explain. So you can add a child node like this. You can select a scene, select player, and you can see that player is added as the child of the main scene. Okay, we can test the main scene. Like, first let us save the main scene under scene, save it. Okay, let's run it, and everything should work perfectly fine. But now we can go ahead and add the enemy scene to our main scene. Okay, you can just drag it, and now we can see that we've added the enemy scene as the child of the main scene. So this is a very helpful features of the Godot engine, because we can actually break down scenes into different scenes, so that this avoid clustering this avoid adding too many node to the main game scene. So you can see that now we only need to add two nodes to the main scene, which is the player and the enemy. Okay, so let's go ahead and run the scene. Okay, now there are a few changes we'd like to make. First of all, we have to add some script to the enemy so that it follows the player, and when it gets to the player at a certain distance, it starts to shoot the player. Basically, that's what the game is about. So we are going to add that. Secondly, we are going to animate both the player and the enemy. So let's go ahead and do that. Okay, first of all, let's go to the player scene. You can easily go to the player scene by clicking here on this little icon, open editor, let's click it, animated sprite 2D. And now in our idle animation, we can autoplay, like the same functionality as clicking play over here, but we actually want this to animate when we run the scene. So what you are going to do is click on this icon that says autoplay on load. Let's click it, and now if we run our main scene, we are going to see that our player is now successfully animated. Okay, now you might think that you can just go ahead and do the same thing that we did to the player to the enemy, but I actually wanted to show you guys another way to achieve the same functionality that we did just right now. So, but instead of clicking it over here, we are going to use the script. We are going to use a GD script to do that. So let's create a new script, enemy script. Okay. Okay, now don't forget, at the beginning of the tutorial, we made mention of the ready function that is called when a scene enter the scene tree. Basically, this is called the first time node appears, which is our enemy node over here, appears on the sentry. So what we wanted to do then is to get our animated sprite 2D, this animated sprite 2D, which is a child of the enemy node over here, and we are going to call the play function. And don't forget, we've already named our animation over here. We've named it I do. So we are going to click I do over here, and this should achieve the same functionality as clicking this autoplay on load. So let's go ahead and try it out. Okay, now we've successfully got the player and the enemy animated. So okay, secondly, we want the enemy to follow the player. Okay, seriously, that was a mistake. So, but if you want to hide any node, you can just toggle the visibility button by this little eye icon. But notice that if we hide this enemy node, all these child are hide. So when we hide enemy node by animated sprite 2D is hide, our collision shape 2D node is hide. So this signifies that whenever we perform an action on the parent, because we can see that this enemy is the parent, animated sprite 2D and collision shape 2D are the children. So whenever we perform an action on the parent, it affects all the children of that parent. That's just something to notice. So let's go ahead, open our script. Okay, now we need the enemy to follow the player. How are we going to go about it? First of all, what we are going to use is that let's say we've got an enemy over here, and these are no, let's say this is our enemy, this is our player over here. What we actually wanted to do is we want to get not the angle, by the way. What we actually want to get is another vector that if we keep adding that vector to this enemy, it will move in the direction of the player. So if the player is there and we keep adding that vector to the enemy, it's eventually going to reach where the player is over here. So to do just that, we first of all need to get the position of the enemy, the position of the player. But we can already see that we've run into a problem. This is our player and this is our enemy, and there is no way we can get this player inside the enemy scene right now. So what we are going to do is we are going to add our player to a group. So to add any node to a group, you can easily go to the inspector tab over here. Let's click on the node. Let's click on this group over here. So clicking this plus icon, you can easily add that particular node to a group. So let's call it player, and now we can easily get that player over here. And Let's first create a variable called player, and now we are going to say player equal. We are going to get the whole scene tree by calling the get tree function. We are going to call another function or method which is get first node in group. Like we want to get the first node that we encountered with the name player. So what it does is that it checks the whole scene tree, checking each node for if they are assigned to a group or not. So the first node it encounters with the player group is going to return it and back to the player variable. So now we can easily use this to get our player node. So after doing this is just for testing purpose. Let's create our direction, which is a vector 2. Vector 2 dot 0 is just the same thing as vector 2 0 0, because we don't want our enemy to move at all yet. We don't want that yet. So but right now we can actually go ahead and call this function global position dot direction to player dot global position. Okay, now direction to function is provided by Godot engine by default. So what this returns is that it returns exactly what we want. We want a vector 2 that we add to the enemy node, that if we keep adding it, we are eventually going to reach the player. Now let us test this. Just as before, our process function are going to be adding position plus equal data, our direction, and we also need the speed. Okay, let's go ahead and try it out. Let's reduce the speed a little bit so we can really see what's going on. Let's make it 20 and let's move the player to the center. Okay, now let's just watch this. Okay, eventually this is exactly what we needed. Like we want a direction vector that if we keep adding to the enemy position, we eventually get to the player. And if we get to a certain to a certain distance to the player, we want to be shooting the player. Okay, actually that's not us, that's the enemy. We want the enemy to be shooting the player. But first of all, let's add a bullet to our player so that our player can shoot the enemy is back. Okay, we take a brief break over here and I'll see you in the next part of the tutorial. Hello world, and in today we are going to actually give let the enemy stop when it reach some distance to the player, so the enemy can finally shoot the player. And also we are going to give our player a bullet so that we can easily shoot the enemies. So right now what we are firstly going to do is we are going to go to the enemy scene, click on this little script, the script icon right here, and now we can begin modifying the existing code. So I'm actually thinking about the method that we can use. First of all, let us try to check out the distance to method. Let's see how it works out. Distance to player dot global position. Okay, let's go ahead and run our project. Okay, that is completely weird. I'm not sure I have any idea what's going on. So let's go back. Okay. Oh, oh God. Sorry. This was actually meant to be distance too. I have no idea what's going on. Sorry, sorry guys. Okay. Let's see if it actually reaches zero when it touches the player, and bam. Okay, if you look at this very well, I think a value of 100 will be okay. So you can easily go ahead and check for it. So if our global if the distance between the enemy and the player, if it's less than no if it's greater than some threshold, I'm really sorry for my slow typing guys. um, give it 80. No, or let's make it random. So to generate a random number between a random integer actually between one number and another, we can easily use the random range function. So we pass in the lower the starting range, which is 80, and the ending range, which is 100. So let's go ahead and try this. Okay, and good. Now actually this is exactly what we want. So we can go ahead and increase the value a bit, maybe 50 or 60. Let's leave it at 60. 60 will be perfectly fine. I think you can easily change this to exact any value you want, any value you'd like, but I think that should be okay. Let's increase the speed a little bit. Okay, now let's make some changes to the enemy, and we also get introduced to some new nodes. First of all, we don't want to be following the player every time. We want to be following player because we are following the player every time. That's okay, seriously, the code to even follow the player every time is not currently added. So let's go ahead and copy this with Ctrl C and paste, Ctrl V. Let's ensure that we paste this above this condition over here. Okay, now what we actually want to do is that we let us test this first to see if it works correctly. Okay, now this works correctly, perfectly fine. But we want some interval between the chasing, so we don't want it to be like that. We want some interval. So first of all, let's use the node that we've explained that the node is used for grouping. Let's use this to group what new nodes that we now call the timers. So all the timers will be added as the child of the node. So let's add the timer node. A timer node is, just think of it as a countdown, and when we've count down whatever time we set, we can easily get when the time reaches 0 using what is called signals in Godot's engine. So I will explain signals later on, but for now let's go ahead and change the time to like 5 seconds, because what we want is we want the enemies to be chasing the player every 5 seconds. We can actually even change this from the code so that it is random and it is not fixed, so that we will have some dynamic enemies. So let's go ahead. First of all, let us name this node timer node. Chase time. Okay, so in the ready function, let's call the chase time dot wait time, which is the same with the properties over here. Let's see it. Let's overwrite the time required for the timer to start to end in seconds. This property can also be set every time start is called. So wait time equal to, now we want a random number between 2 and 5. We can, if we want the timer to start automatically, we can check this auto start button over here. If you want it to run only once, we can check the one shot over here, but we don't want that. We want it to be running every time, every time, every time, so that we can easily change the direction over here. So now what we are going to do is we are going to start the timer over here. Chase time dot start, and now we want to know when the time finished. So let's say that it's like 3 seconds, it becomes 2 seconds, it becomes 1 second. But when it reaches zero, sorry, when it reaches zero, we want to be aware of that. So we can easily use signals to achieve that in Godot engine. So let's go ahead and click on this node over here. Instead of the groups that we used to assign our player to the player groups over here, we are going to click on the signal. So let the signal that we need is the timeout signal over here. You can easily connect a signal to a method. So a signal connected means that this function, so a method, this method or function will be called when the time runs out. So in our example, let's say 3 2 1 0. Immediately after the timer reaches 0, Godot emits the signal via, which is the timeout signal. But we've already connected it with this function on chase time timeout, so we can easily check it out over here. Let's see, print time to chase. Okay, let's go ahead and check this out. Okay, now let's look at our output tab over here. You can see that we are getting time to chase printout, some uh some equal interval. So we can see that the interval are even, so we don't want the interval to be changing. So if you like, you can easily change the wait time as we did over here. You can change it over here, but we don't want that for this tutorial. We want each enemy to have their own unique chase time, and we want that chase time to be constant. So what you actually want to do is, you want to only, when the chase time signal is emitted, that we actually want the enemy to chase the player. So let us paste it over here and let's test this out. Okay, now we are getting some very very cool bits. I like this. Okay, it's coming back. Wait for it, and there you go, there we have it. Okay, now let's make some few changes to the enemy again. Okay, let's give it some minutes. Pardon my very very old PC, I'm really sorry. Okay, what you actually want to do now is, if we notice the enemy, we notice that if the enemy runs out or from the screen, uh, we don't actually see the enemy anymore, and we don't want that. We don't want the enemy to leave the screen and just disappear from the screen. What we want is that if the enemies reaches like outside of the screen from like this place over here, we want the enemy to teleport back to the screen from here. The enemy leaves the screen from the top over here, we want it to teleport to the bottom over here. So let's go ahead and do just that. So now what you are going to do is like, we are going to I'm coming. First of all, let us try this. We want this and cloud. Okay, I think, wait a minute. Yeah. I think it's wrap. You can easily check it out over here. Wrap. Godot actually have a built-in documentation which is very helpful. So you can see that we don't even need to visit our web browser to check out all these documentations. We easily get it directly from the Godot engine, the Godot editor over here. So let's read it. Okay, this is exactly what we want. Wrap difference variable between min and max can be used for creating loop-alike behavior or infinite surfaces, which is exactly what we want. We want the enemy to kind of like be looping around, so we don't want the enemy to go off the screen. So let's go ahead and position. Actually, we are not going to just use it as a vector. So let's go ahead and do this instead. So what's the main value? That should be 0. And what's the max value? That should be, don't forget, we have our project setting, we have our window, we have this width. So that should be our width, which is 640. 640. The same thing for the y position. And that's 320, because our dimension is 640 by 320. So let's go ahead and test this functionality. Okay, wait for it. Okay, but actually this isn't the perfect solution for it. We don't want this at all, and we will actually change this later. So but for now we'll be fine with this. So let's go ahead and change the player also, the player script. Let's go by here, click on this. Okay, now the first thing we actually want to do is, let's go back to the preview of our game. You can see that if the player goes off the screen, we are actually not seeing any player anymore, and we don't want that. So we actually want to limit the player movements. to some certain amount, so that we can actually just maybe just very close to the right like this. We can't move beyond this. We don't want to move beyond this and stuff like that. So let's go ahead and do just that. So instead of using the wrap function that we use for the enemy, we are going to be using the clamp. So what this clamp does is that it limits the position of our enemy. So let's just go ahead and create it by a clamp. So we'll first pass it the value we want to reference, which is our position dot x, yes, position, and the minimum value, which is 0, and the maximum value, which is 640. So let's go ahead and do the same thing for the y position. So our minimum value for y position is what, which is 0, yeah, 0, and our maximum is 320. So let's go ahead and try it out. Okay, now let's fix a lot of things in our game, because we don't want a very a not so good game, and this is an example of a not so good game. But before we continue, I want to explain some certain things. If we look at the enemy scene, we notice that we have this little plus icon like over here. Okay, I'm not sure if you can see it very well, but if you are following this tutorial, you would have already seen it by now. So this, you can see that as we move the enemy, the icon also moves with it. This is because this little plus icon over here is actually our scene, or let's just use the node, our node's center point. So this is actually the the main point of our node. So that this is why when we are writing this code over here, that you should clamp it to 0. What is actually clamping to 0 is not from over here. Oh, sorry, it's not from over here, over here. But what it is actually considering is this dot at the center of our node over here. I'm not sure if you can see it, but if you are following along this tutorial, you have already noticed it by now. So what you actually want is that you want to take note of this. My go-to way of doing this is just to have like a size. Okay, it shouldn't be, or wait, I'm not sure if vector should be constant, but maybe our size is 32. The size of our sprite is 32 by 32. Okay, good. And now let us offset this value. Shouldn't be minus, should it? Yeah. What we actually want, what we want to do with the code is that for when the player want to change the player uh, origin point, but not in a sense, because we won't actually be changing the player's origin point over here. What we'll be changing is how, where we are detecting
where we want the player to actually like stop. No, the clamp function actually does just that, to limit a value to some certain amount. That's what the clamp function does. So now what you're actually going to do is to limit it, so that instead of the code to be considering this place, the code will now be considering this place, which is exactly what we want. So what you're actually going to do is to add, this is 00 over here, to add half of our player sprite, the size of our player sprite. So let's go ahead and do just that. You can easily multiply it by 0.5. It's the same thing as dividing it by 2. Okay, that's for this side. The next side, which is over here, what we actually want is we want to also want to also shift it to the center points over here. So instead of adding to it, we're actually going to subtract the half of the player size. Excuse me. uh I'll be back in a jiffy. Please, I'm so sorry for this short interruption. Okay, now let us continue with the tutorial. So wait a minute. I actually want to check out something. Hopefully, I think I've made some silly mistakes over here. Okay, no mistake, I think. So what exactly is going on? Okay, let's go ahead and do exactly as we are, as I've explained earlier, and it should work perfectly. Okay, now we can only move to some certain extent. Okay, this is very good. Okay, now let's go fix the enemy. The main issue with the player is also the main issue with the enemy. So I won't be explaining things for now. So let's create our size. Let's make the size of our enemy, which is 32 by 32. So okay, now let's go test out our scene. Okay, maybe not what we want. Yeah. It's a little bit different from what we want because uh, the enemy and the player are a little bit different. For the clamp, that's exactly what we want, but for the wrap function, we don't want that. We want this enemy to leave the screen before it got teleported at the other side of our screen. Okay, let's say that the enemy is here and it already got teleported over here. We don't want that. We want the enemy to leave the screen completely. And don't forget that uh, by adding to our origin over here, that we actually let our enemy to be teleported if it's like over here, if it's touching the edge. So we don't want that. We want it to leave the edge over here completely before it got teleported over here. So what we actually do is to just do exactly the opposite of the clamp function. So instead of 0 plus size dot x times 0.5, we're going to use 0 minus size dot x times 0.5. Instead of 320 uh, minus size dot y times 0.5, we are going to use 320 plus size dot y times 0.5. So let's go ahead and paste our scene, sorry, again. Okay, perfect. So so good. This is exactly what we want. Okay, this tutorial is getting long. I think we are going to be adding bullet next. So I'll meet you in the next tutorial. Stay safe and I love you guys. Thanks so much for the 100 plus views. I'm very grateful. So bye for now and I'll meet you in the next tutorial. Bye. Hello world and welcome to the next part of the tutorial, and today we are going to be updating our player scene. So we are going to be adding bullet to our player, and we are going to be adding a bullet to our enemy. So first let's go to the player scene, and so let's go to the script. And now what you actually want to do is first of all, let's go over to the project over here, project setting, and let's go to the input map. We can already see that we've already have the some input that we can use, and we have this shoot, which is a X, to be triggered by the X key. So now we are going to add the code to do that, so that the player can shoot with the X key. So you can still use the input dot sorry sorry so we are going to pass in the name of the label of our input map, which is shoot. So going to guide if input dot is action press, this is X for the shoot. So first of all, let's go ahead and print some words shooting. Let's go ahead and run our scene. Alright, let's run the main scene. Okay, so now if I press X, I'm getting shooting, but I'm getting it way too much. Like if I just hold the X, I'm going to be getting shooting, and we don't want our player to just keep shooting the enemies. That's going to make for a very good game. So now we are going to add a timer to help slow down the rate of shooting, the rate of this code being triggered, so that now we can set like a cooldown timer. So now let's go ahead and do just that. And before we proceed, I think I've discussed about grouping earlier in the tutorial, but I'm still going to go over it briefly. So to group nodes together, maybe enemies node and etc, we can easily add the node. Yes, it's a node called a node. So now, and we can use it to group that node. So let's go ahead and use it to group all the timers we'll be using for our player scene. So let's go ahead and add the timer node, and under the inspector over here, the inspector tab over here, we can set the wait time, which should be around maybe 0. No, maybe 0.2, and let's set this to not one shot, but let's just leave everything as it. You can change the process call back over here to visit. So now we are going to add an and. So what this does is that is first of all check for this if input dot is action price is shoot, and then it check for the other condition over here. If both are true, then the block of code over here is run, gets run. So you can check that if the timer. Okay, wait. First of all, let's rename it to cooldown timer. It's very important to name your nodes, to give them a very descriptive name about what they do. Dot You can easily check for the time length. The time length is less than or equal to 0. So this gets run, and now what you are going to do is under the, okay, first of all, let's go ahead and create the ready function. Don't forget, the ready function is being called when the node enters the scene tree. So under the ready, we are going to start the timer, the cooldown timer. And now let's start. So what this does is that when the game first run, if we press the X key, we are not going to shoot any bullet until after 0.2 seconds, and after that we are not going to shoot anything anymore. So we are still going to have to start the timer over here. Okay, I just noticed a silly mistake. Let's set this to one shot. Right, so I think everything is set. So let's go ahead and run the scene. And so now if I hold the X, you can see that we are getting what we want. We are getting what we want, and this is very good. This is very good. So now let's go ahead and add the bullet to the player. So to add the bullet to the player, we're going to go back to our library sprite. Okay, let's just wait for it to load. And in the meantime, let's delete this printing. It's a very good idea to always remove all the printing, uh, because they are only used for debugging purpose, and once we debug our code, we can just remove the print. So all the print function shouldn't be in your program. So now what is, okay, let's go right here. Okay, now we are going to make it a system by system pixel. I've already discussed about this in the pixel art tutorial. So if you haven't watched it yet, you can do so first. So, and there are a lot of great tutorials out there. So let's click on the horizontal symmetry over here, so that anything we draw over here gets reflected on the other side over here. So let's draw our bullets. So okay, so I want the bullet to be something like a cylinder, something like that, and very sharp mouth like this. You don't have to necessarily follow exactly what I'm doing. You can just come up with your own bullet. And now what are we going to paint this bullet? Just paint it red. Just paint it red. So this this should have more brightness over here. So more saturation, and for the shading part. So I believe we've actually had a good grasp on what's going on right now. And if you haven't, you can kindly check the pixel art tutorial. Okay, I think there is something powerful running in the background, so that is why we are getting this. So let's just wait for a moment, I think. Okay, now we can continue with our drawing. So let's make this less saturated. Let's drag it over to the purple area. So that was good, but it can be better. Here it's okay, we're not going to make it like this. I'm going to make it like this. Let's increase the saturate decrease. You don't have to follow the exact steps that I'm following. I'm going to give a link to the asset in the description. So if you actually want to use this asset, and so we are going to actually create a two frame because we want the enemies to also have a bullet. So the enemy bullet is going to be less saturated compared to the player bullet because we want the player bullet to stand out than the enemy bullet. So let's go ahead and just follow the same process. And so now we are done with both the player bullet and the enemy bullet. So we can just export our sprite sheet over here, and let's just name it bullets. Click the export, and now we can finally use our asset in the code over here. So now I'm going to create a scene. I'm going to add area 2D, and let's rename it to uh, bullet, and let's add the sprite 2D. And now I'm actually going to explain some basic usage of this node. So with the sprite 2D, you can just add any image you want to add to the sprite 2D. Like sprite 2D is used mainly for displaying graphical components of games. So since it's graphical component, we're going to be needing an image. So let's go ahead and drag the bullet image to the texture property over here. So and now we have our image displayed over here in the game scene. So now what I want to explain is this animation properties over here. So you can see that we have lots of variables over here. You have the H frames, you have the free frames. The H frame is just like horizontal frames, and the free frame is just for the vertical frames. So now we can actually add how many frames do we have in the horizontal frames, and we can see that it is 2 because we have the player bullet over here. We also have the enemy bullet over here. So let's go ahead and increase this to 2, and the free frames is just 1. We only have a 1 vertical frames. So now if we increase the frame over here, you can see the frames gets changed to the next image, which is 1. And since we only have two two frames, so we can only change it between 1 and 0. So 0. So that's all about the animation panel over here. So it's very helpful and can come in handy for your game development journey. And now let's go ahead, and since an area 2D node needs a collision, let's go ahead and add it. I'm going to add a collision shape 2D node. So under the shape, let's change it to capsule. I think capsule should be okay. um, I think, yeah, let's just leave it like this. So let's go ahead and save our scene. So let's add a script to our scene, to our blessing. Oh, sorry. Before that, I think there's something we need to do. Mm, let's delete the bullets script. So now let's create a new scene. I actually wanted to use this to explain a feature, because we could have easily create a bullet for our player and our enemy directly from the bullet scene over here, but it's a little bit complex for beginners, so we are not going to do that. So we're actually going to create a completely separate scene for, sorry, we are going to create a completely separate scene for our player and our enemies. So now you can easily instantiate this bullet scene. So what this does is that we are actually going to take all the nodes from this scene, and we are going to like import it to another scene. And now, but since we are importing it from this blessing, any changes we make to these blessings uh, is going to be up to update over here. You can also think of it like as what we're actually doing over here, but instantiating is a little bit different from that, because now this, if we actually make some changes to our player, we can easily like uh, maybe add something to it, and maybe like change some value over here from the player scene, and such value is not going to reflect over here, but that is completely different from instantiating, in the case that every change we make over here is going to reflect over here. So let's go ahead and instantiate the blessing, and now you can see all this yellow, all these nodes, they are colored in yellow, which means I think uh, we have like some limited changes we can make to them. I think, I'm not very sure, but I think that, because there are sometimes that I actually want to edit an instantiated scene and I'm going to get an error. I'm not even sure we can delete it, so they are only here and they are here to stay. So now we have a separate scene over here. Let's remove this to the player bullets, and now we can save the scene. Player bullets. Now we are going to add a script to our bullets, and now let's quickly add the two basic function, which is the id function and the process function. And we are going to create some variables like the speed, the direction. So let's name this vector 2 0. Let's make it a constant, because I'm going to be changing it like 100 and okay. So first of all, let's go to the enemy player scene and let's create a variable for the bullet scene. Let's name it I'm going to load the file of the bullet scene. The player bullet is over here. The bullet scene that we've created, and so now let's add the bullet to the player. But first of all, I'm not sure we're going to add it to the player directly. And I'm going to see why I said that, because we actually want to add it to the main scene over here. We don't want to add it to the player scene, because don't forget, if the root node over here, which is the player over here, if it got moved, all its child we also got moved. So if we add the bullet as the child of the player, what is going to happen is that when we move the player, the bullet also moves, and we don't want that. We want the bullet to move on its own. First of all, we're going to make sure that the bullet position, make it a global position, not local. We are going to set it to the player position, and now we have this we've set the player bullet to the current location of the player. And now instead of just adding it, using the add child function over here to just add it as a child over here. Animated sprite 2D is a child of player, collision sprite 2D is also a child, and timers is also a child of player. But cooldown timer is not a child of player, it's a grandchild of player. So now if we use the add child function over here, it's going to add uh, the player bullet as a child, just like the animated sprite 2D and the collision shape 2D. So, and we don't want to add this as the player child, we want to add it as the main child. So let's go ahead, and we are going to use something called grouping, and I believe I've already discussed about this. So let's add our main scene to the main group, and now we can easily use uh, we can easily get our tree and then call the function of get first node in group, passing the main, and then we are going to call the add child function, and we are going to pass in the player bullets. And now let's go ahead and run our scene. And now let's go ahead and click X, and you can see that we are now getting our our bullets on this scene, on this screen. Sorry. So cool, this is cool. And now let's go ahead and ensure that the the bullet is actually following the enemies. So when I shoot, I'm going to shoot the enemies. So now this is going to get a little bit trickier, but first of all, let's go ahead and add our enemies into a group of enemies. So now under the player bullets over here, you can easily set the direction, our position. You can actually just go ahead and do this, just add it to the speed, add speed to it, the direction, and multiply everything by delta, which is very important, so that we can get uh, a consistent frame across all devices, despite of their of how fast they are. So but still on stage now, if you run the scene, we are going to get nothing, because the direction vector is actually not doing anything, because it's just zero. And if you keep adding zero to something using multiplication, sorry, we are actually going to get zero. Anything multiplied by zero is zero. So now we don't want that zero. So let's go ahead and add what is going to make it move by changing its direction vector. I'm going to see why I said this might get a little bit trickier now. Let's get a variable, div direction vector, and now we're going to get our direction to the enemy. So actually, we are still coming back to this, because this is just like a placeholder, and this code is not perfect yet. We are going to refactor all of this, and this is very good, because what you're actually building now is like a prototype that we are going to build on later. So we can easily get our direction to the player, so that we can easily add it to the bullet, so that the bullets know that this is where I'm going, and if I keep going here, there's a possibility that I'm going to reach the enemy and kill the enemy. So let's add a global position dot. We are going to add a direction to, and don't forget, this is not the final code, and we're actually get tree. We're actually going to change a lot of things over here. Enemies. So you can easily now go over the p bullet and change the direction to equal to the vector. And now I'm getting a 1. Oh, sorry. Yeah, to the enemy global position. So now let's go ahead and see what this does. Okay, now this is looking like a game, so we can see that we can now shoot the enemy. And sorry, the bullet is moving a little bit slow, but it's a good start. So you can always change things later on. to ensure that we are getting a very good game. You can always change things over things. And now if I hold the X, you can see that there is a like cooldown for the player, so that the player is not just shooting tons of bullets so to the enemies. So and now this is very very good. And I think the next thing is to actually rotate the bullet so that the direction it is facing is is to the location is actually going. So now let's go over to the bullet. No, I'm not going to go over to the player bullet over here. Now let's rotation for the player bullets. I just rotation bullet rotation. That makes a lot of sense than the latter. And now what we're actually going to do is global position dot angle to point, which is a dot first noding group. And you can already see that there is a lot of redundancy going on over here. Like we are calling this function too many times. You can just set it as a variable. And as I've said earlier, we are going to actually refactor things a lot in the next section of the tutorial. But for now, let's just go ahead and just try things out. Global position. And it's still not going to work. I think how I fix this, just so I add a pi to it. So this is like I'm adding like a 45 degree, because the way the rotation works doesn't work from up over here. Like it works a little bit weird. So like it starts from here instead of starting from here, and this is the location, the direction the bullet is facing, and not here. You can easily fix that by just rotating the bullet, the player bullet, but let's just do it in code over here. So this is what we use for the rotation. I think this should work. So we are just going to add a play bullet dot rotation. We are going to set it to the bullet rotation, and let's go ahead and try things out. Okay, I'm not I can't even believe this works once, because most of the time when I'm writing code, getting it to rotate perfectly used to be some of my major problems, I think. But with time, uh, I've get to understand how the rotation actually works. This uh these methods over here, the angle to point, is not the only method that we can use. But how the angle to point works is that the angle being calculated is just assume that this is the direction of your scene that you're actually trying to rotate, and which is not so. You can already see that this is also even also facing over here and not here and not over there. So that's how the rotation works. And for now, I'm just going to like add a node over here. Let's name it the bullets. So this is going to be the place that we are going to add all the bullets. I'm not sure I should add any prints, but I think I should add the underscore over here. uh, it's not a must. I can also add it over here, which I think makes more sense. So let's just, and now we are going to go to the player scene. Let's go over here, and I think, yeah, over here. So change to bullets, and let's check if everything works perfectly. I'm also going to use this medium to explain the remote over here that we get once we start our scene. And now I can just go over the bullet node over here, and you can see that we are getting bullets added to our node, our bullet node over here in runtime when I'm running the game. So now I can keep shooting, as you can see that now we have a node. And so this is this sentry that I was talking about. So when a node enters here, the ready function gets called, and that's all about it for this tutorial. And in the next tutorial, we're actually going to refactor things a lot. We are going to add more enemies. We are going to add, I'm not sure we are going to start with the HUD, which is just a fancy acronym for heads up display. And I think that's all for this tutorial, for this part of the tutorial. So stay safe, and I'll see you in the next part of the tutorial, uh, where we are going to add a bullet to our enemies and the player. Till then, see you soon. Bye. Hello world, and welcome back to this chapter of the tutorial. And today what we are going to do is we are going to be adding the bullet to the enemy so that the enemy can finally shoot the player. So first of all, let us go to the enemy scene over here. So let's click on this icon, and actually what I actually wanted to do first is to add another timer over here. Let's see why organizing things is very, very important when creating your games. So let's name this shoot time. So we can go over the inspector over here, can change the process call back to physics, change the wait time to like maybe 3 seconds, so that the enemy can shoot the player every 3 seconds. We can toggle on the auto start over here, and now we are going to connect the timeout signal. Click on connect, and this is where we are going to verify the code later on. So first of all, as usual, let us test things out. Okay. Okay, now we can see we are getting the yellow over here. Okay, we are getting the yellow printed out in the output. So now, first of all, what we actually wanted to do is you can remember from the last topic that I said the code we're actually writing is for now still a prototype, and we're actually going to refactor many things. So let's go ahead and start doing that. First of all, I'm going to create a variable. Okay, we already have the player variable over here. We don't need to create anything anymore. So we already have the player over here. So now we are going to test if the distance between the player. Okay, actually I don't want that. Global position dot distance to the player dot global position. And now, first of all, let us test this out. I think we've already explained about this when we talked about the enemy movement. We've already discussed about this. So yeah, 82, no, 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 120, 203. I think 203 is actually very, very, very good. Okay, I think I'm going to go with 200. So let's go with 200. I think 200 is great. Okay, so we're actually going to create a condition for that. So now okay, let us continue. Now, first of all, we are going to create the enemy bullet. Don't forget how we create the player bullet. We are going to click on the new scene over here, or click on Control N. So we are going to click this insert sheet new scene over here. So scene, I'm going to click on bullet scene, and now we can rename this to our enemy bullet. And now we can hit Ctrl S to save our scene. It's a very good thing to do too, or it's a very, very important to always save your scene very often, because sometimes the Godot engine might crash. So you want to ensure that you always save your scene. And now we're going to create a new script, enemy bullet.gd, put it in the right location, and we are good to go. And just like the player bullet, so we can just go ahead and copy things. And now we're going to make a few adjustments and the speed, maybe 80. Okay, and just like how the player can shoot the enemy, the same way the enemy is going to shoot the player. So So I think that's direction to player dot position. And don't forget the rotation also. I believe I've already explained this in the previous part of the tutorial. If you haven't watched it yet, you can do so by now, and I recommend doing so before continuing the tutorial. And okay, so let's create a variable, the enemy bullets variable. We're going to reference our enemy bullet scene. Okay, sorry. Let us name it enemy bullets. Let's put the S so that we can easily name this enemy bullets. We set the position of the enemy bullet to equal to the current enemy, which is actually the current position. We must ensure it is actually global position. Don't forget, if since we are actually not going to be transforming this node over here, you can easily leave it as position instead of global position. Or if you like, for scalability, you can just go ahead and use the global position for scalability and consistency across our code. So now let us forget the name of this node that holds all the bullets in our game, which is the bullets. The name of the group is bullets with this underscore as the front. So now we're going to get our tree. We're going to call this very familiar function. And now we're going to add the enemy bullets. And I think we are good to go, except some few adjustments like the rotation. And again, we can easily set it to global rotation instead of local. I mean, if you leave it as just rotation, we are going to be using local instead of global. So for consistency, just use a global over here, and I'm going to set it to equal to this. And now let us go ahead and test our game. Okay, I'm not sure this is working. It's not working. It's very much not working. Okay, good. The direction. Oh, sorry, my bad. All this simple mistake are actually very common when you are creating a game. So let's name is we're going to let it go to the enemy bullet direction, and things should work perfectly fine by now. Okay, I think the timer is not working perfectly. This is actually very slow. I don't want this. This is very slow, very slow. So we are actually going to make few adjustments to the timer node later on. Okay, I think something is wrong with the code. Okay, so let's go ahead and try to figure it out. Okay, let's go to the node over here. This is the enemy bullet. Okay, this is the okay. So let's try 300. Yeah, our enemy scene. Let us change the wait time to 2 seconds, and also we're going to add the print function over here. Just print anything. Okay, something is very wrong with the code. Okay, I'm coming. Okay, I think I know what is wrong actually. So first of all, I think .abs method this should uh, I'm trying to look for absolute, so that we are not getting uh, this negative sign symbol over here. Sorry, sign, so that we are not getting negative sign. So I think that's what is causing the error. So okay, now let's go ahead and, oh sorry, not over here. Okay, we are still getting the same error. Oh gosh. Okay, sorry guys. I'm very very sorry. So it should actually be less than, not greater than 300. So my mistake. That's a very very silly mistake. I'm very very sorry. So now things should work as expected. I can already see that the bullet is actually very slow. You don't want that kind of bullet. The player is also very slow. So let's go ahead and fix all these stuffs. First of all, let us delete all the prints in our codes. So now uh, let's change the enemy bullet speed to, I don't know, maybe 140. Okay, player bullet to 160, and the player speed, let's change it to 400. So let's go ahead and check it out. Okay, I think looking good. Maybe. Yeah, I think it's very very looking good. We get what we want. Good. So now let us crank these things up a little bit. In our missing, let's create a node called node. Let us name it the timers. So this is actually where we'll be adding all the main scene timers. So let's add another node, a timer node. Let's name it enemy timer. So we're going to set the wait time to, I'm not sure it's actually matters for now, because you're actually going to reduce this waste time with time, so as to increase the level of difficulty, so that the game is actually not easy. No one loves a very easy game. We want to make things a little bit difficult. So let's connect the timer signal, and we are getting an error. That's because our main scene doesn't have a script attached yet. You can already see any node with a script attached, you're going to see this little icon over here. And if you go to our main scene, we don't have that icon, which means we need to connect a script to the main scene. So let's go ahead and do that. And now, first of all, you can right click this signal over here and click on this disconnect. You can already see that we can also click the delete button if you want to disconnect signal. So let's connect it again. It disconnects, and now what I'm actually going to do is when the enemy timer's time runs out, we're going to add a new enemy to the scene. So first of all, we need the a reference to the enemy scene. Okay, let's just name it enemies. So I believe the steps are now familiar. So create an enemy. And now we're actually going to set the position to be equal to a random number from top. We're actually not going to make it at this 0 point over here. We want to bring it down at 16 by 16. Don't forget all our node size are actually 32 by 32, and if we divide 32 by 2, we're going to get a 16. And don't forget the origin point is actually at the center. This is why we are dividing it by 2. So we're going to start generating it randomly from 16 by 16, 16 at the x and 16 at the y position. We're going to end it at our screen width minus 16 and our screen height minus 16. So don't let us forget. Uh, I think the size is like 640. Yeah, 640 times 320. So now let's go back to our code, and I'm going to set the enemy position. Don't forget, it is very recommended to always use global position. Okay, sorry for that. So although sometimes you're actually going to use uh, the local position, but as for me, I recommend always using the global position. And if you later realize that using local position makes more sense than using uh, the global position, so you can easily use that. So range from 16 to, that's 320 minus 16, which is 304. So range from 16 to, that's 640 minus 16, and that should be 320. Sorry, that should be 624. Hopefully I'm correct. Yeah, I think yes, I think it's correct. So and we're going to be adding it to not the main scene directly. Don't forget, it is very recommended that you keep things organized. So name it enemies, and so don't let us forget, you can easily reference this using the dollar sign over here. enemies. I'm going to call the add function and pass the enemy. And now, don't let us forget, our timer node has a one shot. This one shot triggered, which means it is only going to run once, and so we need a way to restart the timer. Yeah, to restart the timer. So you can easily set it over here. Enemy timer just starts. So, but first of all, let us discuss about this. The wait time that is going to start from 10 seconds, but we're actually going to reduce it gradually to make things difficult a little bit for the player as he progresses throughout again, and to keep things fresh. So now, first of all, let us set it to equal 10, and every time we add a new enemy to the scene, we're going to reduce the wait time. You can set any number here, and we don't want it to actually equal some threshold, and so I think if it is greater than this, 2 seconds, let us use 2 seconds. So what this does is that we don't actually want enemies to be popping in our scene almost every second. So to prevent that, that's why we set this new condition over here. So we can also print the wait time so that we can easily monitor how the variable changes. Okay, now let's go ahead and run our scene. Okay, let us wait for 10 seconds. 10 seconds. Okay, looking good. So now you can already see that the wait time is now 9.8. I think there's already a mistake in the code. I think first of all, let us close it. Okay, just what I suspected. We are now setting the wait time to equal to the new wait time that we we change it to. So you can also rename the variable to wait time, because who knows, you might actually want to add another wait time to the code. So to avoid naming conflict, let's put to the front so that we can easily know that it is an enemy wait time. So and everything should works perfectly. Okay, sorry, let's go ahead and debug the wait time. So E just stands for the enemy. If you like, you can use all these shortcuts if you can remember it very well, and you can easily add a comment if you want, like what might help you to remember what a variable stands for, just in case you might forget. So you can easily add it using this hash symbol over here to add a comment. And so don't let us forget, all comments are going to be ignored by the compiler or the interpreter. So let's go ahead and run it. And now we are going to wait patiently. 9.8. Actually, we can ignore all these 0.00000001, so we can easily ignore that. A very cool idea just popped into my head right now. Like whenever the enemy just stands, whenever the player just stands over here and probably isn't moving at all. So we actually want it so that when the enemies start shooting, like they are shooting the player right now, and they notice that the player just stands there, not moving, no action being performed. And what this actually does is that after some time, they finally leave the player alone, and later they will still come back to the player and start shooting. So I think that will make for a very good game. So also once the counter reaches 2, we are going to end it for this section. Before, I thought we are going to discuss about the HUD, which is the heads up display, so that we can easily display the player heads, the player bullets, and so on, all those stuffs as we probably see in games. Okay, I'm not sure the code is working. Alright, I think it does. I know exactly what went wrong. So this should actually be greater than or equal to 2, and so everything should work perfectly right now. So if it doesn't, please kindly leave it in the comment below what went wrong, and we will be revisiting it on the next part of the tutorial. And for the player scene over here, We are going to be revisiting it also in the next part, and we are going to be discussing about the HUD so that we can add some cool stuff to our game. And I'll see you in the next part of the tutorial. So stay safe and bye for now. Hello world, and welcome to the next part of the tutorial. And today what we are going to be doing is we are going to be creating the HUD. HUD just stands for a heads up display, so that we can use it to display stuff like the health. And for example, let's say apart from the player health, we also want to display like maybe bullet. And so that for that we are going to be using the HUD. And so we are going to be discussing some basic nodes that we use when creating the HUD in our games. So but first of all, let's go ahead and fix some problems relating to the player scene and the enemy scene. So first of all, let's go to the player scene, and what I actually want to do here is ensure that everything is probably set, correctly set. For starters, um, there are a lot of errors going on in here. So I know what you might think that maybe what is the error. So first of all, let's go ahead and still run the same game again with no modification whatsoever. So this is exactly where we left the previous part of the tutorial. And let's say I shoot uh, the enemy, and we can already see that right now that there are a lot of problems here. Okay, first of all, if I believe the game fashion that you already have is probably uh, the enemy are not shooting these green bullets. So let's fix that quickly. And so how we get the enemy to be shooting the green bullet is by going to the sprite over here. This is actually a feature of the sprite 2D node, and that is it can take, it can take a sprite sheet. Sprite sheet just contain more than a single sprite, so in a single image, but the image contains not just a single sprite, so we have many sprites. As you can see in this sprite sheet, we have the player bullet, which is the red over here, and we have the enemy bullet, which is the green over here. And so this is where we left on the last part of the tutorial, but we've already specified that on the horizontal frames we have this frame 1, this is frame 2, and on the vertical frames, which is up and down over here, we already see that we have only a single frame. And so this is what is specifying the H frames and the P frames. But if we want to cycle through the frames in our sprite, we have to change this frame property over here. So you can easily click this up arrow over here to increase or increment it by 1, and this down arrow to decrease or decrement it by 1. Or you can just click the value and just enter a new value. And so we want to set the value of the frame to 1, so let's go ahead and do that. And sorry, let's go to the main. So I just click run current scene, And so now you should get this fashion. And the problem I actually want to enunciate about is well, first of all, we already see that if you shoot enemy, the enemy are not dying. If the enemy shoot us, nothing is happening. But what I want to enunciate about is if we actually want the auto shooting to be shooting the closest enemy, and so you can already see this is the enemy I'm close to, but I'm shooting another enemy. I'm not shooting the correct enemy, and so that is the problem I want to shed some light on. So now we are going to do those three. First of all, if the player shoots the enemies, we want the enemy to actually die. And when the enemy shoots the player, actually we don't want the player to die immediately. We want to give some players some health, so, and we will discuss about that later. And thirdly, we want to be shooting the closest enemy. So we don't want to just be shooting random enemies. And so let's fix that as quick as possible. And if we fix that as quick as possible, we are going to get back onto our HUD, which the tutorial is actually about. And so let's first of all go to the enemy bullet. No, we are not. We don't. Let's first go to the player bullet. So this is the player bullet. Well, first of all, we want to discuss something about signals. And so, well, this area 2D has what we know as an area, and this area is basically defined by this collation shape that we define over here. So this is the area of our player bullet. So we can enlarge it. We can obviously choose whatever we want that area to be, but it has nothing to do with the sprite 2D. So remove the sprite 2D over here. This is still the area of our player bullet, and so sprite 2D is just there for just visual representation of whatever it is we are representing. And so we are going to do, well, first of all, this is the player bullet, so the area should be a little bit large. So we want to give the player who is going to play our game that feeling of control, and okay, we are shooting the enemies, and we are realizing that okay, we are killing them actually. So, and this is why we are actually expanding the position shape over here, and I think this looks good. And now we actually want to detect when this area, don't forget, by saying area, the area is actually defined by this collation shape 2D. This you can already see the future representation. So we want to detect when this area enters this enemy scene. So let's say it is from here. So we want to detect that okay, we are actually hitting the enemy, and when this happens, we want to perform an action, and that action will be to remove the player bullet from the scene, because obviously it has performed its function, and to actually kill that enemy, which can be done by just removing the enemy also from the scene. And so how do we go about this? Well, to go about this, let's go to player bullet and let's discuss something about signals. And signals is basically what gets fired when an event happened. And in our case, events will be the player bullet, the player bullet entering into the enemy area. So that is an event because it is entering a new area. When it leaves the area also is an event. When it enters the tree, and even we can already notice that this ready function It's like an event, because when when a node get added to the sentry, the ready function gets called. So that is an example of an event. When something happens, we do something. In our case, when the player blade reaches the enemy area, we want to do something. And so this is where we get a lot of signals, and you can mouse over all these signals to get a basic idea of what the signals is about. And the signals we are looking for is this area entered. We want to get we want to we want to know when this player bullet enters a new area. So this is basically what happened with the area entered signals over here. So let's mouse over it. You can already see uh, emitted when the received area enters this area. Emitted is just the word used for called. So you can use called, you can use emitted, it's the same thing. And you can already see that the description says that emitted when the received area enters this area. So the received area is the area that is incoming, which is the enemy, the enemy area. Don't forget the enemy is also an area 2D, and this is one of the extended functionality of area 2D. Don't forget, uh, nodes have all this pre-built functionality, although we can extend them using scripts, using JavaScript. So now let's go over here, and to connect this area with our script, we can double click it, and you get this sub window. And this little prompt over here uh, is asking us to connect this signal to our script. And so you can easily go ahead and click the connect over here, or you can, if you've already defined the function that you want to connect with this signal, you can just click the pick over here, and you can pick that signal from the drop down that is going to show over here. And if you are not seeing that function that you defined, you can disable this script method only, or compatible methods only. I think don't disable this script methods only, just disable this compatible methods only, and you should be good to go. But in this tutorial, we are not, or we don't have a function created already. So, and we can easily create that function here, but let's leave it as on area entered. And so let's click on connect, so that we can connect the fence with this new function. And so first of all, what you are going to do is you are going to check if the area that I will get is actually in the group of enemies, and where was this area coming from. You can already see that we are getting that area variable over here. So it's getting passed to the emitted function. And so to check this out, you might just print that area, the area group, area dot is get, I think it will get group something. So you can go ahead and try this out, but you already know what is going to get print out. So I'm going to create an if check. If area dot is in group, don't forget the name of the enemies, it must matches uh, what we define, which is enemies over here. If you are not sure if you are going to get it right, you can just right click the group and just, I think if you click rename over here, you can just copy it, or using the control Z and just paste it with control V, or you can just click over here to copy it. So what we're going to do is, we are going to first of all, no, we are not actually going to first of all delete the player bullet. This is something I actually want to discuss about. If we want to perform a function or anything by this player bullet script, but we've already delete the player bullets from the sentry, that function might not get called, and you are going to run into some problems. So first of all, what you are going to do is to delete that area, which is the enemy, and we do that by just calling the queue_free method. And what this does is that it removes it from the sentry. I'm going to discuss about this sentry later, but right now we are using this line of code to delete the enemies, any area that we entered, that the player bullet entered, sorry, with this group of enemies. We are going to be deleting that area. And now, after deleting that area, don't forget we still have to remove the player bullet. So let's do that. So to do that, you can just call the queue_free method. Sorry, let's call it queue_free, and everything should work perfectly. But don't forget, we still need the enemy bullet also. So enemy bullets signals, I believe we've already discussed about this. If it entered an area, but this time I'm going to check if what group do we assign the player. I believe that should be player. So, and it's a good thing to always check to confirm if you are getting that the group uh, that you assigned right. And so when this happens, we are not going to actually delete the player from the scene, and so we don't want that at all. So what we actually want is that we want to decrease the player rate. So, but first of all, let's go to the player script to see if there's any variable with health. No, 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 no. So let's go ahead and create a variable called health. The reason why we are not naming this player health is that well, it's already a player script, so it belongs to the player. So we don't need to like name this player health. That is very, very not necessary. Although if you think you might confuse this health with something else, you might name it player health. Although I don't recommend it, because you can already see that we are opening a file named player.gd. So definitely this belongs to the player scene. And so the player blades over here. uh, let's go to the enemy blades, and what I'm going to do is I'm going to reduce the health by, I think 10 is okay. And after that, we're actually going to delete the enemy bullet. And so it's a good thing to check, because don't forget we've only done two things before moving on to the HUD, and it remains one thing actually. So, but first of all, let us check if what you actually fix is working correctly and as we intended. So okay, so let's go ahead and, well, oh, goodbye. And okay, this is Also, a mistake that I actually want to discuss about. Let's say I've killed all the enemy. There is no enemy in the scene now, and let's say I go ahead and shoot. Okay, there's another one. Go ahead and say that I go ahead and just shoot and look at what will happen. Okay, there's another enemy. Let's shoot it. Goodbye, and let's shoot. We're going to get into an error, and we are going to fix this very soon. We are going to fix this very soon. But first of all, let's fix that third error, that if we have too many enemies in the scene, we actually want to be shooting the one closest to us. So first of all, it's a good thing to avoid repeating yourselves in code. And if you realize that you are calling, like you are getting some values repeatedly, it's a good idea to it, and it's a very wise idea to store such value into a variable, so that you only need to use the variable in your code. And that's what we are going to do. We are going to create a variable for, well, target enemy. Don't forget this target enemy. This little code there is actually what you are using to shoot the enemy. And there is a problem with the code, and that's what I want to fix right now. And so you can just change this to target enemy. And also we don't need this code anymore. This get 3 dots, get first node in 3. We don't need all that. And let's just go ahead and replace it with the value target enemy. And so what we actually want to do is this: to get the closest enemy to the player. This is what we are going to do. We are going to actually look through all the enemy. We are going to check their distance to the player, and we are going to check uh which one has the closest distance, the smallest distance to the player. I know this might be a lot of taking if you are not very the into all this programming stuff, but the idea is very easy, because what you're actually doing is that we are just getting the distance of uh, every enemies and every enemy, and what you're doing is we are comparing it with the previous enemy, and basically that's what the code is about, and we are going to compare them together. And so the result that we get is this will let us know which enemy is closest to the player, and that is what we want. So let's go ahead, and I'm going to create a for loop. So this is going to loop through all the enemies. And so what do you want to do? Well, for starters, I'm going to call this if. Don't forget, we already have this first one to begin with, this the first enemy. So we are going to call this function if target enemy dot distance to. Okay, don't forget, you don't just want to be calling the distance to. Sorry, I mistake. And don't forget, always use global position. Global position to the oh, sorry, dot distance to. So this is going to return the distance to the player position. What we're going to do is if it is less or if it is greater, um well, we're actually going to be using greater. Sorry, I uh, I was thinking about something when I was writing it, but I think this should work perfectly. as we wanted. Global position, and what we want to do is uh, to to add line breaks to your code. You can click Alt Z. So, and now what we're going to do is we're going to make the target enemy to equal to I. Don't forget I is just, maybe let's not use I as a variable. Yeah? Let's just use enemy. But let's append it with underscore. So let's go ahead and change this also. And this also. And so I think we are good to go. Yeah, I think we're good to go. Okay, let's go ahead and test the same. I just realized this tutorial is getting long, and we might have to discuss about the HUD in the next part of the tutorial. And I'm very, very sorry about this. I'm really sorry about this. Okay, which of them is closer? Which of them is closer? Which of them is closer? Okay, you are closer to me, and you are closer to me, and of course, you are closer to me. Closer. And so this is it for the tutorial. Um, I'm going to be adding all the scores, the health, and the bullets in the next part of the tutorial. I believe this little side tutorial has been quite helpful. If it does, please hit the like and the subscribe button, and I'll see you in the next part of the tutorial. Thank you, and bye. Oh gosh. Hello world, and welcome to the next part of the tutorial. And in today's tutorial we are going to be discussing HUD. So what are HUDs? If you've been following this tutorial, you've already know what HUDs are. HUDs are it stands for heads up display. So just think of it as uh, like a secondary window when you are playing your game. So it's like an overlay that display all relevant information. For example, if you've played games with combat system like RPG games, they have HUDs. Like the inventory is HUDs, but in this simple game, our HUDs are going to be containing the player health and the player score and the player bullet. The player bullet is just some nice juice that we are going to be adding to our games. I believe I've discussed what juice are in the previous tutorial. So let's go ahead and add HUD to our game. Sorry, just please give me a minute. I'll be back very shortly. Okay, so welcome back to the tutorial, and so let's go ahead and get started. So first of all, let's create a new scene, and most of the time when you are creating HUDs, you are going to be using some specialized nodes that we use when creating HUDs. And so we are going to be introducing new nodes in this tutorial. So first of all, uh, ensure that your root node, the main root node of your HUD scene, is actually a canvas layer node. The reason why we are using this is because of, well, let's first check the description. A node used for independent rendering of objects within a 2D scene. And what was meant by this was like, when you are creating your HUDs, you don't want the HUDs to be moving with the camera. You want their position to remain fixed relative to the camera, so that when the camera moves, they don't leave this the view, the main camera view. And so this is why I recommend using canvas layer as the root node. So let's go ahead and add it. You can simply rename this to HUD, and well, now let's go ahead and save our scene. And so when if we want to add the health, or the score, or the bullets, there are different ways to achieve this effect in Godot. uh Sorry. So the first one is to just use plain text to display the health, or the scores, or the bullets. So to display any text, we use the label node in Godot. So you can already see the description over here, a control for displaying plain text. So, but of course we have the rich text label that gives you more intuitive control over the text formatting. So, but we are going to be sticking with label for the text part, because don't forget there are different ways to display the health, the bullet, the scores to the player. So now we've created a test, but of course we don't call them tests over here, we call them labels. So to add the text to the label, you are going to go under the properties tab over here, or the inspector tabs over here, and you're going to change the text property to whatever you want to display. So you can use it to display health 0. So well, the player died, obviously, because if the player hasn't died, the health is supposed to be greater than 0. So you already see that, wow, we have our very first HUD. But of course this isn't the approach that we are going to use in this tutorial. So what I firstly want to explain was the margin container node. If you look at this node very well, you realize that the nodes, the test nodes are, let's just call it the label node for simplicity. So you can already see that it is displayed as the origin, which is the 0 0 coordinates over here, and most of the time you don't want your player Z to stand over here, you want to move it down a bit. And so to add uh all these extra spaces to your node, we are going to be using the margin container node. So there are a lot of container nodes, but and we explain quite a bit uh, in this tutorial or future tutorials. But for now, let's go ahead and add the margin container node. And so you want to make sure that the margin container is the parent of the label. So now we are still not going to see that much difference, but now we can click on this margin container, go under the theme overrides over here, go under the constants, and then we can change the margins that this margin container is applying to all its children. So that means since the label is only the children for now, it is going to apply to only labels. Okay, now you can already see that we are adding some margin at the top. Let's check it. I mean, the margin that we're adding at the top is that is 50. The margin that we're adding at the left from this place, and that is also 50. From the right, that is 20, and from the bottom we are adding no margin at all. And so this is very useful, so that our labels or other nodes that we are using for our HUD doesn't get stuck at this origin point over here. And so now I'm going to explain two nodes quickly, the box container and the box container. And so let us say that we already have our margin container, we've set our margins, but now we are looking for like a way to arrange all the children's either vertically or horizontally. By vertical I mean all the children's get stacked vertically. For example, think of it as menu. We can have the play button here, we can have about, we can have settings, we can have a seat button, and so that is what we use the box container for. And for box also the same thing, but instead of arranging the children's vertically, they are going to be arranged horizontally. And so right now what we are going to do is this: we are going to be adding more nodes, more label nodes. So to duplicate the nodes that we currently have on the scene, we are going to click Ctrl D, and so now we should have 4 label nodes. The reason why we are not seeing any difference is because, well, we can already notice some slight and subtle differences, because you can already see that the health is very much darker and more bold. The reason why we are saying that is because we actually have 4 tests displayed on the scene. The reason why we are seeing it like just a test is because we are displaying all the 4 tests in the same position, and so that is why we are seeing this. And so now let us say that we want to display all these label horizontally. So let's go ahead and add the HBox container. So you can check the description over here. A container that arranges its child controls horizontally. Don't forget the words that were used here. Uh, its child controls horizontally. So let's go ahead, and now we're going to move all the label nodes as the child of the HBox container, and watch what was being showed over here. You can already see how they are stacked horizontally. And so this is label 1, label 2, label 3, label 4. And so this might actually be very useful for our HUD. For example, let's say you want to display health over here, but you also want to display something else over here. So the reason why we are using all these HBox and FitBox containers is because we want to keep things organized as want to keep things as organized as we can, as best as we can. And so uh, to check for that of the FitBox container, we don't have to delete the HBox container. Don't forget, if you delete a parent node, all the child get deleted. So actually what you are going to do is, we might have noticed that if we over the HBox container, we get this little description that says the name of the node is HBox container, but there is also a type. So the type is actually what matters in when you are developing games in Godot. So if this is also a canvas layer, but the type is not a canvas layer, we won't be getting the result that we want. So the naming actually doesn't really matter. What matters the most is the type. And so now what you are going to do is you are going to right click the HBox container, click on change type over here, and now we are going to change this to FitBox container. And voila, we're going to see that well, we are getting our labels stacked. Instead of horizontally, we're actually getting it stacked vertically. Don't forget, it is still HBox container, but the type is now FitBox container. So to avoid confusion, you can go ahead and rename it to FitBox container. And so I believe we've covered a lot about the nodes that were used when creating HUD, and we are actually going to stick with label for this relatively simple game and a very small game. You don't want to go into the advanced topic yet. Okay, so now let's go ahead and get started in creating our HUD. First of all, I'm going to delete the FitBox container, and let's go ahead and add HBox container. And I'm going to quickly discuss about uh, what this little, I think this is the anchor. So we can easily use this to set how our container is going to be displayed in uh, in our scene. So you can set it to top left, uh, center top, top right, or top wide, or however you want to set it. So when we click on this, we already get a visual uh, a visual preview of what is going on. So we are getting That's little nice feedback over there. So we can actually set the magic container to take the size of the full screen by just clicking this full right over here. But we don't want that. We want it to take the top wide because we want our HUD to stay at the top. And so the first HBox container, we can also set uh how we are actually going to how it is going to get displayed as the child of whatever it is a child of, which is in this case is the margin container. And so you can set it to shrink begin, just like this is actually a little bit different from the anchor preset that I'm using over here. And so you can set it to if you want to set it to take the full width available, you can just click the under the horizontal alignment, you can click the fill. If you want it to take the vertical space available, you can click the vertical element and go ahead and click the fill. Okay, so now we are going to add two label nodes for uh, for the health and for the score. And so this is going to be the health, and this is going to be the score. And so you can easily set the health to equal 100 to begin with. So 100 is the max health and the score is obviously 0. And since we want the score to actually align to the right over here, we don't want it to get stacked with the health, so you can easily go to the score nodes, go over the alignment, and now first of all we want to click this expand so that it is not shrinking the size to the only space that the node is going to take. Don't forget, this score is only going to take this space, and that is why we are getting this little, I think it's orange, this little visual representation of the size of the nodes. So in this case the score node. So by clicking expand, you can already see that we've resized the node to take the full width that it can actually take. And so we want to align it to shrink end. We want to align it over here. So, and well, now we have this nice HUD. And now let's discuss more about the labels. So label node has this label setting over here. So let's go ahead, click the new label setting, click on it, and under it we can set the font for our text. So you can easily do this if you have a font file, probably in a TTF file. You just drag it from over here and drag it to the font property over here. We can change the size of our text over here. You can change the color, so you can just give it any color you want, and you can add an outline. You can give the outline a color. You can add a shadow. Don't forget to turn on the alpha. So alpha just means the transparency, how transparency a color is. So and we can set the offset of our shadow over here. But actually we're not going to be using any of these for now. So what we are going to do is we are going to change the size of the text to, let us use 24. I think 24 is okay. And we are going to change the color of the alt. We are going to change it to red, and our score, we are also going to use the red color. And now let's go ahead and save this scene. So we can just drag the HUD scene so over our main scene, just drag it anywhere. Don't forget it is going to position it not relative to any position, but actually what you are going to get is a position, since we are using canvas layer as the root node. So let's go ahead and run our scene. And of course we are getting the HUD displayed properly. Okay, this is great. And in the next tutorial, actually, we are going to be adding, we are going to be updating all these UIs, the labels, so that the health reflect the health of the player, and the score also reflects the score of the player. So that will be all for this part of the tutorial. And don't forget, if you've gained a thing or two, don't forget to leave a comment, hit the like button, and subscribe. Thank you and stay safe. Bye. Hello world, and welcome back to this part of the tutorial. And today we are going to be updating the HUD that we created in the last part of the tutorial. And so first of all, let us go to the HUD scene, and we are going to attach a script to our HUD. So now we are going to creating some couples of functions in our HUD script. So first of all, we are going to create the set score function. Takes in an argument of score, and we are going to use this argument to update our score. There is a couple of things that I want to explain over here. So first of all, our score and text property only accept a string. As you can see, if you hover over the text, we get what it accepts, which is a string. And our score is an integer. So we need a way to convert that integer into a string, and we are going to be using the str function to do that. So we are going to be calling the function over here, and we pass in the score, and this will fix the problem of adding a string with an integer. So we are going to do the same thing for the else. Okay, ma. Okay, so now we are going to be and updating the out the score label. So first of all, let's go to the main scene over here. So you can click on this icon over here to open the script of the main scene, and now we are going to be discussing about how to connect signals, because now we want to be connecting a signal from the player. First of all, let's go to the player scene and go to the player script, and I'm going to be adding a setters. The way this works is that every time the health value changes, the setter function is going to get called, and so we actually want this because every time the health changes, we want to be updating the label to display the correct health. So I'm going to be setting a setter to equal to a function, and so I'm going to be adding this function over here. First of all, we are going to be setting the health to equal to whatever value we get from the setters. To avoid naming convolution, we are going to be adding an underscore to the health. So, and now we are going to be calling a signal. In Godot, you might frequently heard a signal being emitted instead of being called. They basically means the same thing. So we are going to be creating this signal up over here. It's quite a common thing to place a signal just above the extend uh, uh, line, which is probably basically the first line that we extend whatever type they notice. You can already see that this is area 2D, so that is why we are extending the area 2D. So what this does is that it allows us to use all the functionalities of this area 2D. So after that, we are going to be calling our signal. Let us name it change out. And so we are going to be emitting this signal change out dot emit, and so we can connect this change out dot emit with the main scene. But first of all, let us pass in the health by as an argument, because we need the health. So let's go to the main scene, and I'm going to be making a reference to the player. So let's create a ready function, and over here we're going to be setting the player dot change out dot connect. Now what this does is that it's like we are creating, every time the change out got emitted, we're going to be connecting it with another different function that we are creating. So we can easily go ahead and plug in the HUD and the HUD function over here, but I prefer creating a custom function for this. So don't forget, this is where the changes is getting emitted, and we are passing in an argument which is the health. So let us call this a change p out. So p just stands for the player, change the player out. So let us create the function, and don't forget the argument out. And so we're now going to call the HUD dot set health, the function that we've already defined, and I'm going to pass in health, and this should work perfectly as we expected. But let's go ahead and test it. First of all, we need to ensure that, let's go to the enemy bullet. We need to ensure that every time, okay, we are already doing that over here. So every time the bullet hit the player health got reduced by 10. So no, I'm not going to select that. Okay. Okay, now we can see that the health is getting updated as expected. Okay. Okay. Okay, there is a couple of things that we are going to do like first of all, we are going to set the limit of the health so that when the health reaches 0 and the player receives another hit, it is going to be a game over. So we are going to do that. We are going to be also adding the game over scene, so which is part of our HUD, by the way, and we are going to be adding the start game scene, which is also part of the HUD. So first of all, let's go ahead and update the score so that when the player destroys an enemy, the score got incremented by some amount. And by incrementing, I mean the score got increased by some amount. So let's go to the player bullet. Let's go to the script, and here is where we are going to be incrementing the score. So first of all, there are a couple of different ways to communicate signals with different with nodes. So we've already seen a way of doing this with the player scene that we used earlier by just emitting a signal. but of course there is another way of doing this, so we are going to be discussing the other way in this. So we are not going to be setting the score over here. Let's go to the main. So this is where we are going to be setting the main, the player score. So score is going to start from 0, but at the same time we need a setters for this. Just call it change score or change p score, just to keep things consistent rather. So throughout our code we want to keep things we don't want to change how we are naming things. And so again we need the score, and here we are going to be setting we're going to be calling our HUD function, the HUD function, which is this set score that we've already defined earlier. So HUD dot set score, and I'm going to be passing in score. But first of all, this is very incorrect code. First of all, don't forget we need to set our score to equal to the value that we are getting, which is the underscore score. So now let's go ahead and test this thing. Okay, now let me destroy a player. I'm going to be seeing no changes because we are not updating anything when we destroy an enemy. So let's go ahead and do that. So you can already see that we can update the score over here whenever we destroy an enemy. So but instead of going through all the process of emitting signals or anything, you can just get the main scene over here through the group. The main scene is in the main group, and we are going to be changing the score property of the main scene. So that is exactly what we are going to do over here. So and so we can be incrementing the score by, I don't know, maybe 50. You can change this to whatever number you want. So let's just leave it at 50. And now let's go ahead and test this in, and everything should work perfectly. And voila, you can already see that when we destroy an enemy, the score got incremented by 50, and so we can already keep playing our game right now. But first of all, there are a lot of fixes that are going to do to this game. The player and the enemy bullets are moving very slow, and we're going to be fixing that now. And also we are going to be spawning a lot of different enemies, so let's go ahead and do that. First of all, let's go to the enemy scene, to the animated sprite 2D, and let's just create lots of enemies. You can click over here to duplicate the current uh, animation. So it is enemy 2, so we can duplicate it, and I'm going to be creating, I think, 5. So let's go ahead and do that. I believe I've already explained the process of doing this in our previous tutorial, so this shouldn't be a problem at all. And so how we are going to be doing this is in the enemy script, uh, in the ready function over here, we're going to be playing a random uh, animation, so that's from our animation list. So first of all, let's create an array to contain all the animation list. So enemy 1, so we have enemy 1, enemy 2, and enemy 3 to enemy 5. And so now that we've created the array, we're going to be picking randomly from the array. So I just say animation list dot pick random, and now we should be getting a random enemy every time the enemy gets spawned uh, on the main scene. So let's test that out. Okay, that's a different enemy. That's another different enemy. So I already see that we are getting a very different enemies. So, and of course, you might be wondering, how are we going to be differentiating between the player and the enemy? Of course, there is no way of differentiating it, but you can already see that when we press the arrow button, we already saw the player getting moved. So that's how we are going to be knowing uh, which of them is the player and which of them are the enemies. So now let us go ahead and make changes to the player bullets and of course the enemy bullets. Okay, this is actually looking very good. So And so I think we'll be wrapping things up for now. So probably in the next tutorial we are going to be adding the background, and I don't know, maybe we are going to be discussing about light in this game, but it's a very short game and I don't want to make things complex. So well, that will be all for this part of the tutorial. And if you gained a thing or two, hit the like button and be sure to leave a comment and subscribe. Thank you and bye. Hello world and welcome to this part of the tutorial. And in today's tutorial, actually, we are going to be covering the game over scene and the play scene. So that that's what we are going to be covering in this tutorial. But first of all, we can just easily go ahead and delete this enemy scene over here. So we don't need to instantiate the enemy scene anymore. So you already got the enemy timer doing that, so we don't need to do that anymore. First of all, we need to go back to the HUD, and here we are going to create another margin container. So let's just name this game over. And so first of all, let's go to the anchor preset over here. I'm going to set it to full rect. So now what we actually want is we want a label. We want to add a label node as the children. We want it at the top. Actually, I think first of all, let's go back to the inspector of the margin container for the game over. So go over this theme overrides property, go over the constant, and so we're going to be adding some constant 40, 60, 40, and maybe 20. We can actually change this later on if it doesn't match our game over scene. So now we can easily go ahead and write the text game over. And so we're also going to display the player score over here, but we don't want to display it with the same label. I'm deeply sorry for the noises. So but as we've discussed earlier in the previous tutorials about the how to hide the label setting, so we are going to do that for our game over scene also. So for the font, actually we want to change. I want to explain the font property of the label. So for any text, if you actually want to change how it looks, so if you want to change the font that the text is using, by default is going to be using some predefined font. So if you want to change it, we are going to be dragging a font file to this font property over here. So we already have this Kenny Fuchonaro font file. So the link to this font file will be available in the description. So we can just drag it over to the font property. So I will do the same thing for the text, and I will do the same thing for the label. So now let's change the size to maybe 50. We want to change the color to maybe this red. Okay, I think that's very okay. I'm not going to be adding any outline, but we can add the shadow. You can just change these things around to suit your needs, so you don't have to follow exactly what I'm doing. So I also want it to be centered. And so if you want to duplicate a node, you can easily press Ctrl D to duplicate the node. So now we can already see that we have this the same text, the same label setting, and we don't want that actually. So this should be your score is. So but if you change the size, we're going to see that both the first label and the second label size are getting changed. This is because both of them are referencing the same label setting. By referencing, I mean both of them are using the same label setting. And if you want to separate it so that label use his own separate label setting, and the label 2 also uses his own label setting, we're going to right click and right click the label setting over here. I'm going to click this make unique, and so what this does is that it disconnects the label 2 from our first label. So if I click the make unique over here, and if I just go back to the font size and change things, we're going to see that we are getting the effect that we actually want. So you can make this maybe green and make it dark. Also, we don't want it, we want it to be transparent actually. So it's not a must to just copy exact value that I have here, because obviously we want this color to have a very warming color, a very peaceful colors actually, and that's why we are choosing color green. And for the shadow, we don't want any shadow at all, so we can just click that. And okay, we are getting some stuff to write here, but because we don't want this your score is to stay to not it down over here. And to do that, uh, okay, well, first of all, since we encounter such an error like this, a problem like this, don't forget we can actually use a container to align all of our labels. And this is a very good time to see the node in action actually. So don't forget, since we want to align them vertically, we are going to be using the ferret container. So let's just go over here. Oh, sorry, I meant the fig box container actually. So you can label these as you can rename these as labels, and we are going to be dragging all of our labels as this child. Okay, right now the issue that we were fixing earlier has been fixed. So now we can add another new label that says that your I score is okay. The reason why I'm adding this your score is and your I score is to actually explain some other few functionalities like how to save data in Godot, the Godot engine. So there are various ways to save our data because our I score is actually going to be a data. So we can easily do some basic check like if our score is greater than our I score, we want to change our I score because we've already beaten our I score. So that is why we're adding all this your score is and your I score is, and that is for the labels. And you also need the buttons. We can also go ahead and add the free box container. So but we actually need the age box container, so because we want like a menu button over here and a restart button over here. So uh, you can already see that it's taking the full width and height, and we don't want that actually. We also don't want to center it, but you can just put it around here. I think here should be fine. And so we are going to be adding the buttons. They should be menu and another button. But here we can just click this shrink end, so that don't forget to choose this expand, so that it's going to be taking the full width available. So yeah, we're going to make this restart, and right now we can actually I was thinking I don't think we want it to be vertically aligned to the center, because if you want to you actually want to make some future changes to this thing, we want it to be as responsive as we want it to. So if you click the shrink end, we can easily go to the margin container, and we're going to change this margin button so that we can control where those two buttons are. So just drag them up over here. You can also change the margin right and the margin left. So but to ensure that the nodes are centered, we are going to ensure that both the margin left and the margin right have the same value. So if you are going to be using 70, uh, the margin right also should be 70. So I think it looks okay right now. But if you actually want them to be more centered, you can easily change the margin left and the margin right. So I think let's just leave it at 70. I think it's okay. And right now we can change the buttons name, menu, and restart. And before we connect the press signals, if uh, if you don't know what that was, when we click on this button, if you want something to happen, we are going to connect the press signal with our script, our HUD script, or other scripts in our scene. But for now, before we do that, we can easily customize this button. If you go under if you go under the theme overrides, you can change the color. You can change the font that the this button is using. First of all, let's change the font actually. And we're going to change the font size also. Um, the 48, that's too big. Maybe 20. Let's stick with maybe 24. Let's stick with 24. So we are not going to make any changes to the button yet. You can easily go ahead and change things, and you can change the if you want, when we hover over the text and we want to change the color, you can change the over here. So the font over, and the normal font color, you can change it here. When you focus on this, you can change this over here. Font color, font focus, and font outline. You can easily go ahead and just try all this out, and they are not that difficult to understand, but for beginners I would recommend you try them all out. So but we are not going to be explaining all those functionalities in this tutorial. So and right now we are going to be adding a texture rect. So the reason why we are adding this texture rect is because we want uh, this game over your high score is all these nodes from here to here. We want them to pop out when the game is actually over. So we are going to be dimming everything else, but we don't want to dim all this game over because that's the main information. And so what texture does is that we can use it to display a texture like an image, but we can also use it to display like a tide texture. So definitely we are going to be using a texture instead of a sprite 2D node. So to add the texture, you can easily add the texture over here, and we want a gradient texture. I just stick with this gradient texture over here, and if we want it behind all other nodes, now uh game over node, so we're actually going to place it before all other nodes, so that it now stays in the background and the other nodes are displayed on top of it. So now when you click on this gradient, you can change the values of the gradient. The gradient is moving from here to here. We can actually change how it moves so that it doesn't flow from left to right. So but for now, let's just go ahead and just change it to some white, both of them to some kind of white. Okay, I think that's okay. So for now, we're actually not going to be using any of this, but first of all, don't forget we need to connect the pressed signal for both the menu and the restart button. And so right now, let's go ahead and save our scene. It's very important. Also, sorry, we need to hide this game overs, this game over node over here. The reason why I've been calling this since sometimes is because we can actually extract the scene from here. If you just click on this, we can create a new scene from over there. So when I said scene, I meant the game over node over here, this magic container, and all is child. So that's what I meant. So also, I think I've explained this, that if you uh disabled the feasibility property of a parent, it gets applied to all the children. So when we disable this feasibility property of the game over, all the nodes inside it feasibility are also disabled. And so we're going to actually create a new scene. So this is our menu scene. So we don't need it to be elaborative. We just can easily add a node. Don't forget we use node for grouping, but we can also use it for a root child of a root uh, a root node of a scene that maybe has no functionality at all. So, and that's what we are doing over here. So just name this menu. So we are going to be adding yet a margin container, and we are going to be setting it so it stays at the bottom. Don't forget to click the expand over here. You can already see this is not working. The reason why it's not working is because of this root node, which is the node. Because don't forget, the node has no functionality at all. So we mainly use it for grouping, and so there is no 2D coordinate that we are telling this magic container to resize to. So well, you can see that we can still use the anchor preset. It's going to be using the our game scene resolution. So you can easily use that. So now we are going to be adding uh a VBox container. So and here we are going to be adding buttons as the children. So before we do that, let's go over the inspector. Let's go to the theme properties over here. We're going to be changing the margin left, margin top, margin right, and the margin bottom. And so this is going to be our play button. And so as usual, let's change the font. Let's change the font size. And we're going to be duplicating this node actually 3 times. So this is going to be our about, This is going to be our exit. So let's add in the appropriate text, exit, and about. And again, we are going to be adding a texturate as the background over here. Don't forget, we want it before the margin container. We want it to actually take the full rect, so we know exactly where to do that. And let's go ahead and change the color. You can just change the color to whatever you like. I think this looks good. You can add more color by just dragging and just clicking on an empty area. So if you actually want to add another color over here, I can just click over this and new color gets added. And when I right click, we no longer have that color in our color ramp. So this is actually a color ramp actually. So I think that look okay. Let's save our scene. And we are going to be attaching a script to the menu scene. And we are going to be connecting the pressed signal for play, for the about, and for the exit button. For the exit, we just want to quit everything. So to quit the game, you can just call the get tree function, and we're going to call the quit method of the get tree. For the about, we just leave it as it is for now. So for the play, we actually want to change the scene to the to our main scene over here. This is the main scene. But first of all, we need to load it. So let us name it. Let us create a new variable, name it game. Then let us load this scene. And now we're going to get our tree, and we're going to call this for method change scene to pad. So we're going to pass in the game. There is another way to do this actually. You can just call the change scene to file, and we're going to pass in uh, the location of the scene file. But since we've already loaded the game scene, you can just call the change scene to pad. So now we can run. We can click on this play button over here or press F5. So, and we are going to select the menu scene as our main scene. So when the player runs the game, the player is actually going to land in to our menu scene first. And so let's click the play, and the player can easily play our game right now. So also there are some things that we'll be adding in the future, but right now this tutorial is getting long. We've not finished with our HUD functionalities yet, because we've not set the game over condition. and we need to set it. So that's what we'll be doing in the next tutorial, and we'll be fixing some stuffs also. So I'll meet you in the next tutorial, and stay safe. If you found the video helpful, please leave a like, a comment, and kindly subscribe. If you want to support the continuous development of the tutorial, you can support me on Patreon, or you can kindly buy me a coffee. So thank you so much for joining me in this tutorial, and bye. Ooh, game over. Yes, I got shot. Okay, okay. Hello world, and welcome back to this tutorial. And in this tutorial, actually, we are going to be completing our HUD. And so first of all, we are going to be adding the loose state. So um, let's go to our HUD, and over here we have to make some few changes. First of all, to the functions that we defined for the restart. When the restart button is pressed, actually we want to fire the signal that just reload the current scene, which is the main scene, the main game scene. So we're going to call this reload current scene function of the get tree. So when the menu button is pressed, we are going to take the player to the menu. So first of all, we need to load it. uh, don't forget how we did that uh, for the menu scene. We create a variable that just reference the the scene that we want to load. So we are using this load function over here to load the scene, and we're going to use the change scene to packed uh, function of the get tree method. So we're going to do the same thing over here, but there is actually another way to do that. You can just call the get tree dot uh, change scene to file instead of change scene to packed. We're going to reference main the main scene. So now we need the game over function. First of all, when the game is over, we want to display the game over. To change the visibility of a node from um, disabled to enabled, we can just call the show function over here. So the next thing we want to do is actually to pause everything in the game. So we're going to call the get tree dot post, and we're going to set this value to true. And so what this does is that all the nodes allows it pauses all the current nodes that are currently running in our scene. So starting from the root node is just going to traverse the tree. So by traversing, I mean it's going to go through all the nodes and just stop all of them. So to avoid the to avoid the paused this pause property being applied to the game over node over here, we're going to go under the inspector tab over here, and under process, under this mode property, I'm going to set it to always. And so what this does is that uh, when all other nodes are paused, the game over node is not going to get paused. And don't forget, since we are not pausing the parent node, the same thing applies to all the children. So, and also we need some quick fixes. For example, since we are pausing all the nodes over here, we need to restart. We need to restart that every time we press the reload current scene by setting the pause property to false. But don't forget, we can't just go uh, to the reload current scene. We also have this menu button, and so we are going to do the same thing over here. This is to avoid the game being freezed. So and so right now, what you can do is you can go over the main scene, or maybe no. Let's go back to the main, and in this change health, in this change health, we are going to check if health is wait. Actually, you know what? If player health is 0, I'm thinking about maybe we should let 0 also be health, but I don't want 0 to be health, so let's all equal to 0. So we go over to the HUD, and we're going to call the game over function. Now the function must match the function name that we defined over here, so which is this game over function. And now we can test our game. And so, well, the head is 0, and now we are displayed this game over scene. And if you can click the menu, if you want to go to the over to the menu, you can click the restart button over here. Let's check if they are working perfectly. So, well, first of all, that is not perfectly. So under the HUD, oh yeah, this needs to be menu actually, not the main scene. Sorry for that. I'm deeply sorry for that. Um, let's check things again. So sure. Actually, I think in the next part of the tutorial we're going to be adding a sound effect, because this game is very boring without sound already. And so we are taken back to the menu, which is great. And click the play again, because we want to check for the restart button. Maybe that also works or not. So okay, perfect. And in the next tutorial we're going to be continue the development of the game. And what I actually want you guys to do right now is in the main scene actually we have we have this transparent background. I want you guys to just add a texturette. Don't forget the texturette is not going to be here. Texturette is going to be under over here, and you want to set it to full right to just take the background. And at the same time we have to create a new scene for the about. So I believe by this stage we can do that actually. So go ahead and try that. In the next tutorial I'm going to show you guys how. So also for the image that we'll be using, you can just you can create the image the from the gradient that we discussed about. But don't forget the image is going to get displayed. So to, the image is going to cover all the other nodes. So we can set it to, you can just drag it over here, so that it stays in the background. And well, that's it for the tutorial, and I'll see you in the next part of the tutorial. So thank you, and if you've gained a thing or two, please subscribe and be sure to leave your comments. And if you want to support the continuous development of the tutorial, you can support me on my Patreon page. Thank you so much, guys. Bye. Hello world, and welcome back to this part of the tutorial. And in this tutorial actually we'll be covering how to add sounds to our game. So first of all I want to quickly go over uh, an error that I encountered when playing the game. And so let's go ahead and run the game. So if I try to shoot now, I get this error that says invalid access to property or key global position on a base object of type null instance. So, and we are getting that because of this target enemy, and our target enemy is null. So what are we going to do in such a situation? So first of all, let's go ahead and create another variable for last move. Set it to effector 2 dot 0, and over here actually I will check if our direction dot x is not equal to 0, and if it's not equal to 0, we set the last move to equal to our last move dot x to equal to the direction dot x, and we can do the same thing for y. And so if you go ahead and over here actually you just pause it, and you can easily check if target enemy if there is no target enemy at all. So if I get enough returned, so what you are going to do is let's copy this first, so space it over here. Actually, let's declare the player bullet over here actually, so we don't need that anymore. So avoid redundancy in our code, and so over here actually our direction effector will be the last move, and also there will be the rotation is actually going to be uh, based on the directional factor. So first of all, let's try to print the direction factor. So okay, I just put this over here. I will change it later on. So if I move up and shoot, I'll still get it. Okay, but I'm not setting the return. You can already saw a lot of an error before we before the game starts, and now there is no enemy. So for now we are going to fix all these errors actually. So first of all, our last move, uh, we are getting some errors over here. So if we don't want any diagonal movement, you can just set the last move dot y to equal 0, and over here you can set the last move dot x to equal 0. Now I believe this should fix all the diagonal movements error. And so this is exactly what we want actually. So and now let us rotate the player bullet based on the value that we set. Actually the player is moving very slow. The player bullet is moving very slow, so let us increase the player bullet speed maybe to 50, and also enemy bullet to 270. So let's go back to the player, and we are getting this directional factor being printed, and we need to make use of it actually. I can go ahead and write ifs, and actually to make things easier, let us use if. Let us use some complex formulas. So I've said if directional factor actually dot x is less than 0, our rotation I think is in radian actually. Yeah, I think it's in radian. So let's check things out a bit first. So let's check this out. Okay, it's working as we expected actually, because this should be pi times 1 point I think 1.5. So let's go ahead and write the condition for all the other factors. So if it's greater than 0, that's pi divided by 2, or pi times 0.5. Don't forget, let's say this is our origin and this is our 0 degree. This is our pi times 0.5. This is our pi times 1, and this is our pi times 1.5, and this is the same thing. This 0 origin is also our pi times 2. So well, this is if our direction is minus, and that's pi times 2, and this one is for pi. And everything is working correctly. So well, that's the error fixed. So I hope you enjoyed how we go about this error. If you are to add diagonal movement, that might add some complication. You see, if I move, let's kill this enemy quickly. Let's click this. Let's kill those. And let's say I'm moving diagonally. So I already saw that the bullet movement is restricted to only some movement, to only some axis. So uh, I can't shoot diagonally. I can't. So and that's exactly what we want for this very simple game. So now let us move on to today's topic. Actually, first of all, I've added this little brown, this little, sorry, little blue, deep blue background to as the image of the texturette for our background scene. So this is our background node that we had in the last tutorial. And if you have any background image, you can just drag it in as over here. So let's say I want that as my background. So but let's just leave it at as it is. So you can create your own gradient. I've explained it in the last tutorial. First of all, when we shoot, you want a shoot sand. So how are we going to go about it? First of all, we need to open our chiptune, and we've got the chiptune, and okay, I'm just randomly checking for a shoot sand that we can use. I think this is okay actually. Okay, I think I'll go with this shoot sand. Just leave it at this. So I'm going to save the file over here. So this is no, actually this is our folder under assets. I'll create a new folder. Let's call it sand, and so this will be our shoot.wave. And so we've saved it in the wave file format, and when we hit an enemy we also need a sand. So I can just click on this boom to generate this sand. click on this boom to generate the each sound. I think I like this. I also go with the same flip over here. This flip, and let's save it. Also died dot with, and that's for when the enemy dies actually. So we need when the enemy is hot. I think I like this sound actually. So save it as hot, and I think that's all we need for now. We also need this leaf actually for whenever we click any buttons. I think that's cool actually. So this should be click, and I believe that's all for the SFX. So let's go back to our Godot again, and to add a sound to our scene, we need to use the audio player node, and we have three version of it. We have this audio stream player, and we have audio stream player 2D, and we also have audio stream player 3D. And this is very good if audio stream player 2D is good if, let's say, you have a 2D platformer game where there are different scenes, and you want the sound to be played based on its location, and the sound volume is also going to be based on the location. So that's when you are going to use audio stream player 2D. Audio stream player 3D for when you want such things, but now you are including a three dimension actually, but we are going to stick with audio stream player actually, because we just want the sound to be played. We're not using any 2D coordinate space to play the sound. So she named this as shoot. And don't forget, we need to keep things organized. Let's create a node. Let's call it SND. SND is short for sand, and let's drag it over here. So I can just drag the sand shoot and drag it to this stream property over here, and I can play it to test it. So first of all, what we are going to do is we are going to reduce all the sound that is in over here, that is over here. So let's go to the player script, and in our ready we are going to do this actually. We are going to get no, first of all, let us call this SND get child, okay, sorry, we'll be creating a for loop to loop through all the child and snd dot children, and we're going to be setting is the volume linear to equal to 0.5. I'm not sure if I get this right, so let's check things out. Okay, I'm not getting any error. I think it's okay, but okay, seriously, what are we going to do to this uh idle state? Actually, you might have noticed if I start the game, uh our last move is actually vector 2, there's 0. We might need to change that actually, because we don't want bullet to just spawn at the center of the scene. So let's give it some default value. So let's say I want to move it in the X position. So I think that's good. And so now what we are going to do is every time we shoot over here, we are going to play this shoot sound, and to do that we just call the play function, and whenever we shoot now, we are going to this shoot music is going to get played. And let's try to shoot, and we are getting our music played. And to check if this is actually working, let's set the volume linear to 0, and okay, it is working. I recommend, if you are creating any game, that you set the volume of all the SFX, as in sound effects, to 0.5, all of them. Yeah, to avoid the SFX volume being larger than uh, um, being higher than the background music volume, and we don't want that for our game. And so that's all about it. And now let's go ahead and let's visit the enemy bullet. No. Player bullet. No. The enemy scene over here. So let's create a node. Let's call it SND, just as we do for the player. And now we need this died, and we also need this auth. So I can just visit the recent and just click on this. If you like, you can just call this also died SND to signify that is a music, if you like. But this is a very simple game, and I don't need to complicate everything. And this is for auth. And so we'll give them the music respectively. So, and this is for auth. And now in the enemy scene, don't forget, we are going to create another for loop again. If you are so lazy, you can just go ahead and copy this and just paste it over here. That's if you are lazy like me. Okay, Now what we are going to do, whenever we got out, actually, so that means actually none of the enemies actually have a health, and we can actually quickly fix that, and because we want the enemies to actually have health. So to do that, actually, I'll be using seriously, I think I forgot this node name. Actually, is it texture button? Uh, okay, okay. Let's not complicate everything again, and let's just use a label to display the out. I was thinking about the, yeah, I think it's progress bar. So this is the node that I was looking for. So can resize it. Actually, you can check under this transform, and let's set the size to equal to 30 30. Let us reset its position, and the position dot x, that's going to be 15. Oh, sorry, minus 15, and for the y, that should be like minus 10. Okay, let's take it up a bit, minus 30, and let's resize things a bit. So let's take it up. So I think that's good. So for this progress bar, actually, when we resize this, well, we got this percentage being shown, and we can set the current value over here. Let's set it to 100, and okay, let's resize things a bit. It should be 30. Oh, sorry, this should be like, let's set it to maybe 40, and for the y position, that should be minus 20, because 40 divided by 2, that's 20, and I think that's good, actually. And so let us place this over here, actually. And now we've introduced another node, actually. So what you are going to do first of all is let's create a variable called auth rate, and let's set it to a random value from 10 to 40. So this is the rate at which okay, we don't want a random number, actually. Let us create a variables, an array, 40 and 40 and 50, and we are going to pick a uh, random number out of these 5, and so every time we shoot, well, we are going to be updating the health. So the player now also gets an health. And so let us give it a setters. And set health, and first of all our health should equal to E, and we are going to update the progress bar. Does value is value property to equal to health, and before all of that we are going to play the alt sand. Also in this player bullet, um, when we shot any enemy, what we are going to do is we're going to call his health value, and we will reduce it um, by the alt rate. This alt rate over here. So there are ways you could have went about this, maybe by giving the player some pickups, and but this is a very simple game and you can explore other ideas on your own. Okay, actually this is very looking to it. I already like it, but for now our alt rate is actually I don't know why our alt rate is constantly 10, and I don't want that actually. So let us check if it's actually working, because it should be picking between the 10, 20, and all those. Okay, this is 30. I like it. So for now we can easily go over here, over the enemy, and we check if our health is less than 0. Actually if it's also equal to 0, and we are going to play this died, and at the same time we are going to before we play the sand, actually we are going to disable the collision shape. To do that we call this collision shape dot set deferred, and we are going to call the disabled, and we are going to set its value to true to avoid any more collision. And after that we await the sand to play finish using this signal uh, finished. If a certain property is a signal, we are going to get this little icon over here, this icon near the finished. So we are going to await it, and after that we are going to remove the enemy. So let us check it out. Okay, I think the died um, The dyed sand is playing very slow, and we don't want that actually. So let's go over here and I was thinking about okay, let's try to increase the pitch scale. Okay, actually, um this is what we are going to do. We are going to create another timer, and in this timer, or we can actually do this actually. Don't let us create any timer. Um, when we set the deferred, when we disable the collision shape, we want to hide the enemy visually. So, and you can do that by going over to the animated sprite 2D and just is visible, and we can just set it to false. And so let us check things out. Okay, we also need to disable the progress bar. Okay, this is getting uh redundant actually, but bear with me for this very simple game. Actually, there are a lot of stuff that are not best practices, but I'm just explaining the game concept over here. And well, that's it for this tutorial. And in the next tutorial, we are going to be adding a background sand, and also we are going to be making use of this click sand over here. So okay, and that's it for this tutorial, and I hope you enjoyed it and you've gained a thing or two. And if so, please like, leave a comment, and kindly subscribe. And if you are feeling generous, you can support us on Patreon. Thank you. Bye. Hi, hello world, and welcome back to this tutorial. And in this part, actually, we'll be finished adding the music to our game. Don't forget, we've already added some music, but for now, let's go back to the menu. We are going to add the click button, the click sign rather. So I've already prepared this background music, sprinkles by I think Matthew or something. So I'll drop the link in the description for the music and all the files I'm using. So well, first of all, um if you are going to use this music in your game, you need to provide the appropriate attributes. So while we've created all this by ourselves, I get this background music from Open Game Art. I believe I've explained this in the previous tutorial. So first of all, we need a sound to play whenever we click on the buttons, whatever buttons it is. For example, we have this menu or restart button. But first of all, let's try adding the sound the traditional way. Yes, sorry. Since we are going to use just a sound, just put it over here. Okay. Okay, now let's go back to the script and let's try it out. And over here, actually, we are going to be using something entirely different, because we need the wait function. Yeah, so we are going to wait for it to finish playing before we quit. But before then, we just pause everything and let's try it out. Okay, first of all, I want you guys to notice the sound when I click the about button and when I click the play button. Okay, you might notice that whenever we change our scene, it just stop our music because we are already changing the notes we are using, and well, that is why. So, and we don't want our music to stop playing because we are changing the scene. So how are we going to do that, and how are we going to go about that? First of all, let us check the exit button. What happens when we click the exit button? Okay, first of all, there is not quitting because of this. And seriously, um we could have also bypassed that by just setting and wait over here also, like I'll wait the click finish The reason why we're adding this is because we don't want the player to be able to click the exit button and also click other buttons, and the other buttons should work. So that's like clicking two buttons, and we don't want that in our game. So also when the player click the exit button, we can disable the play and the about if you want. So if that's something you're going for, there are various ways to go about this, but first of all, we are not going to go about it that way in this tutorial. So first of all, how are we going to play the sound even though we are changing a scene? And this is where globals comes in. So just think of globals as nodes that are independent rendering, regardless of any root node. So they they exist on their own actually. And now let's say this click sound is global. When we change the scene, it's not going to stop the sound because it's a global. It doesn't depend on this menu, this menu root node over here to run. So how are we going to add this click sound as a global? First of all, we need a new scene. Let's call it click, and let's pass in the song over here. And now what we are going to do is we are going to save the scene. We are going to attach a script to it. Don't forget, all your SFX must have um, all your SFX must have a volume of 50% instead of 100. So by setting this volume linear to 0.5, we are setting the volume to 50% instead of 100, which is very important. So to make it global, click on the project over here and click on the project setting. So this is where we set the input map in earlier part of the tutorial. And now let's go over this global tab over here, and we need to select this auto load over here. To make sure that's global, we need to set it over here. To create a global group, we need to set it over here, but we are going to use this auto load. So this auto load will allow our scene to render completely independent of any nodes. So click on add, and now we have this global scene called click. So, and we already have it as a global variable, so we can have access to this using this click. And now let's go back to the menu. Whenever I click the play button, I'm going to call the click dot play, and also over here click dot play, and also over here click dot play. And don't forget, over here actually, sorry, we need to we need a way of disabling all other nodes. So I can just call the disabled property. and set them to true. And now let us test this. And I can click on any buttons. Okay, that's great. But oh yeah, sorry, it has to be clicked. This click just finished, and so let us test it, and everything should actually work perfectly right now. And let's click the about, exit, and let's click the play this time around. Okay, okay, and everything is working perfectly. So right now let us add a background music. So how we are going to create it is just as the click button. So let's call it our theme, and let's pass in the music file. And don't forget, since this is a theme, we also want to change the volume. You might have noticed that I recommend changing the volume whenever you are creating a game. So, and that is because sound is very very important when you are creating a game, and you don't want the volume to be that much. Just set it to 0.75, so this is like 75%. And also we are going to set this autoplay to on over here, so that whenever the scene got loaded, it's going to start playing, which is when we start our game actually, since this is going to be a global scene. So we also need to set this looping under parameters. We are going to set it to on over here. So, and just like the click scene, go over this globals, go file auto load, and click add. And now we have the global scene. And now we don't even need to start the sound, because we've already set this autoplay to on. So okay, let's set the volume to 0.6. I think that's okay. Let's set the 0.65 actually, and you can actually tweak the volume to get what sounds more better. Okay, and that's it for this tutorial. So first of all, um you can easily add the about scene, and before we do that, don't forget, actually, don't forget we had to add the click sound to the whenever we click the menu and the restart in our HUDs. So whenever we click the menu, we're going to play the sound, and whenever we click the restart, we're going to play the sound also. And also a very important thing, under team over here, under this inspector tab over here, we're going to go under the process. We're going to set the mode to always, and the same with click, and I believe that's all about it. So now let us quickly create a new scene for the about. You can just add a scene. I set this to node. We're going to add a texturette for the background. Okay, all of these are what we've explained before. So, but if I want this last first color to be this last color, I can just go over here and go over the recent colors. So and click it, and now we get the color that I want. So I can just decrease this or change the color, but let's leave it as white. So now I'm going to add a label. So all these I've already explained. So I'm just going to add the controls and the description. So I think let's change the font size to 24. I think that's okay, and we can set the color to green. And don't forget, we need a script for the about scene, because we need the back button, and we also want to play the click sound whenever we click the back button. So I've already explained all these steps in the previous tutorials. So actually I want to move it a bit up. So under the position dot y, uh, let's move it a bit, maybe 280. I think that's okay. And whenever we click this button, we just want to go back to the main menu. So, and also we want to play the click sound. I recommend using change scene to packed instead of change scene to file. I've already explained both in previous tutorials, and I think that would be all for the back. So we also need this menu. So we've not saved the about scene. And when we click the about button, so I just about, and that would be all about this. Let's go test it out. And so also now we need you can go ahead and test this, but to avoid long unnecessary repetition in the video, we're going to leave it at this. um uh, I'm 90% sure that it will work. So, and now I quickly want to explain something about light, but I'll be doing that in the next tutorial. So I hope you've gained a thing or two, and if you do, please leave a like, a comment, and kindly subscribe to our YouTube channel. And please and please, if you want to support us in any way, you can buy us a coffee, or if you have any questions or you just want to hang out, you can just meet us in our Patreon page. And yeah, thanks so much for joining us. So hello world, and welcome back to this tutorial. And in today's tutorial, I'll be very quick. And what we are going to do is we are going to be adding some juice to our game actually. So what are juice in game development? Well, juice, think of juice those little extra effects that you add to your game that make your game feel more alive and more interactive. And juice are very very important in games, so you should really add it to your games. So now we'll be going over some juice that we'll be adding. Well, first of all, we'll be adding some juice to the enemy actually. Okay, so first of all, we are going to create a sprite. So, and let's just leave it as it is. So let's make it 32 by 32. So we are going to create a little question mark. And seriously, if you want to mirror what we are doing, you can just click on this. And I believe I've explained that in the previous tutorial. I think that's okay. Okay. Okay, now what we can do is we are going to export it in two different fashion, or maybe even not. So we can just create a new frame, and we're going to make this color red actually. So maybe we're going to add less brightness. We don't want it to be that bright. Okay, that looks good. And now we're going to export it. I just name it question. Yeah, I think that's okay. Okay, now let's go back to the our game, and we're going to pass in the question. And also, don't forget, we are going to change the H frames animation to 2. And also, we're going to first of all, let us go to the transform. We're going to resize this, and we're going to place it at the top. If you want to move it on the, let's say, the y-axis, you can click on control and it snaps it to the y-axis. So I think that's okay. Just leave it as this. Maybe scale it down a bit. Okay. Also, we are going to make it transparent. To do that, go under this visibility property. If you want to disable it, you can click on this, but we are going to uh, change the alpha mode. We are going to tune the alpha mode down a bit by clicking this modulate and just turning down the alpha a bit, maybe 180. Yeah, I think that's okay. Okay, I think that's good actually. So first of all, what we want to do is under the player bullet on the player scene, we want our target enemy dot looking at what we can call on it. We can easily create a variable of frame that we can change, but I want to get this sprite 2D directly from our target enemy. So I think let's try I don't want to do I actually don't want to do this okay, let us check this out actually. Frame two, wait, this is one. Okay, let us test it out. Okay, seriously. I think it's working. Let's targeting the okay, that doesn't work. Okay, I didn't get any error actually. So I'm targeting this, but it's not working actually. It's not working, guys. So I'm actually going to check where we are getting this target enemy, and let me just cut it a bit. So and I'll put it over here, and also over here where I was checking for if you can just add an else statement. Okay. Okay, so there is currently another error that I have to think about how to go about it. Okay, first of all, let us check it out. Okay, I think it is working. Okay, well, kudos to our first juice, and we'll be adding more juice in later tutorial. But first of all, I think what we can do is we can add a lighting. So let's go back to our main scene, inside the node. Let's rename it. We're going to add a point light. So think of a point light as a light that starts from somewhere and just grows from there. So that's what a point light is, and we use it to add lighting effect to our game. And seriously, first of all, um let's go back to Libre Sprite again. Let's create a new 32 by 32, and let's use the circle tool. Let's make it is a little bit gray. Okay, I think this is okay. For the lighting, but this should be brighter than the rest. So let's check if they are symmetrical. Okay. seriously, they are not symmetrical. So I can just say, first of all, turn this off. I can just copy this part and just delete everything. And I'll use the circle select over here. Okay, and I'm going to copy and paste this, and I'll wait on um I'll hit on Shift H to flip the image horizontally, and I'm going to just drag. Okay, it should be symmetrical now, and now let us go and paint it with what we want to paint it. So okay, now let us export it as let's name it light texture. So the white part is going to determine the area where the light gets more brighter, and this gray part is going to determine where the area gets lighter. So now we just pass this light texture over here, and it just paces or hit on control. Seriously. Okay, now first of all, what we're going to do is we're going to position it so that it takes the full space available. And don't forget, what I'm doing when I'm resizing it, I'm pressing control for the snapping. And so we've got our texture, and seriously, we want the scaling to be symmetrical actually. Yeah, something like that. If you don't want the uh, aspect ratio to be in locked, you can click on this. So this is locked and this is unlocked. So also in the energy, I can increase or decrease the energy of the light, and I want a very desaturated energy. So also I'm going to add a directional light, and seriously, I'll add the canvas modulate over here and just set everything to a black. Okay, I think that's okay. Also over here, I'm going to enable the shadow, and let's give it something like this actually. So Let us check the game out. And seriously, the reason why we don't see the effect yet is because the effect of shadow is because we are not defining the area, and we do all of this in the later tutorial. And also, I'm thinking maybe there's really no need to use any light texture at all, so we can just use a gradient actually, since our texture is circular, and we are not really looking forward for this kind of light. So we'll be changing that in the next tutorial. So that's it for this tutorial actually. Hello world, and welcome back to this tutorial. And actually in this tutorial we're not going to be adding juice to our game. We are going to be fixing um, some issues with our game. So first of all, let us go to the enemy scene. Let's go to the script. So this is where we'll be fixing the issue first. So first of all, let's go to the player blades. And in this line of code where we are adding 50 to the score, we don't want to do that for now. We only want to add the score when we've actually killed the enemy. So let's put it here. And also, okay, we can increase the score to maybe 150. And anytime we shoot, we can increase the score maybe like 10. Okay, I think that's good. Okay, that should work. The next thing we want to do is actually this. You can see that our alt sand plays for approximately 0.117 second. That's 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 not even up to uh, a second. So actually, when the enemies actually die, we don't want to just disable the visibility of the enemy. We want to place some we don't want to play some animation, because now we'll be creating another animation, uh um another animation, and we don't want that. So what I can do here is we can use a twin, so that we can create this illusion of the enemy fading away. We need to set the parallel to true. You don't need to pass in true over here, because if you just call the method of set parallel, you are creating you are setting it to true. Also, create twin will allow us to use twins in Godot. Just think of twins as what give us some nice transition in our game. So apart from using it to change one property to another smoothly, you can use it to change to call a method and just pass in some value and change it gradually, which is very helpful in some cases. So now, since we want to twin a property, we are going to call the twin property. If you want to twin a method, you are going to call the twin method. So twin a property, and we need to pass in what object, also known as the node. So yeah, the node I've called the object here. So I'll pass in the animated sprite through the 2D, and we actually want to change the scale, and we can change it to the factor 2, 0.2, 0.2, and 0.17. Duration is in seconds, so that should work as we wanted it to. So what happens with this line of code is we are scaling down the enemy, so it looks like it disappeared. And also over here, I'm going to fade it away. So we're going to set this modulate. Okay, now if we go over this visibility, we have this modulate, the modulate property, and it has like four values actually, and we want to change this alpha, which determines how light. Okay, let's go to the enemy scene, and if we decrease this alpha value, we realize we are not seeing the enemy anymore. Okay, and this is what we want. Actually, there's no need to do this for the enemy. We can just do this for the whole sprite. And we are going to set the alpha to 0. So now let's test it. Okay, you can see that nice fading effect, which is really cool. Even though it's just a subtle effect, is very good, very effective. And now we can easily quickly go over this score and high score. But first of all, let us go over the score. In this game over scene, we are just saying your score is, we are not actually giving any information about score. So let's leave that. Let's go to the menu. No, the game actually. Before we call the HUD game over, okay, actually, when we call this game over, let us pass in the score. Okay, when we are calling this game over argument, game over method actually, we need to pass in the score argument. And now we need to go to the HUD, and under this game over, we are calling game over dot show. Before that, we can call this, let's go to the HUD scene, let's go to the game over, and we have the labels, and this is let's just call it game over score, and game over high score, just call this game over. And now what you can do is we are going to call the game over score, and we're going to change this test value to your score is, I believe that's right. Okay, yeah, that is right. Okay, that shouldn't be, okay, doesn't even matter actually. And we're going to pass in score, and we'll be getting the score from here. So now that should work perfectly fine. Oh yeah, sorry, we need to disable this visibility. And now we can see that we are getting this your score is and we are having our score displayed, and this is really cool. And well, actually in the next part of the tutorial we'll be going over lighting in Godot, and that's it. I hope you gain a thing or two, and the next tutorial, actually apart from the lighting, we'll be going over some more things. So we'll be adding more things to our game, and well, that is all for now. Bye. Hello world, and today we are going to be talking about lightning. So we are going to be adding light effects to our game. So first of all, let us go to the main scene, and we can delete the light 2D that we currently have, and let's just leave the directional light as it is. And under this light node, this is a node named light. We are going to add a colorette, and so we are going to make it just take the full width. So now we can change the ordering to ensure that it is below uh, other all other nodes. And so now we can add the node light to the node. Font light. Under texture, we're going to be adding I'm thinking of a gradient texture today. So over here you can change the fill under this fill property. You can change it from linear to radial. So, and we actually want it to take the full width. So when I'm dragging and I click on control, it snaps what I'm resizing to the screen of the game, so which is over here. So now it is taking the full width, and first of all, I think I can disable this directional light. Yeah, I think that's around center. So now I can easily change the color. This one should be white, and this one should be a little bit lighter. So that's the point of the gradient, the 2D gradient. So you can tweak the properties also over here, but I'm not going to go for this. So I just want to show you guys this shadow. I click on enable, and I think now our players and our enemies should be able to cast shadow. So let us go ahead and test it to ensure that you are correct. Okay, well, why are they not casting shadow? Um, the reason is because we haven't provided a light occluder yet, I think. And so let's go to the enemy scene, and we're going to be adding a light occluder. And over here, ensure that this create point is clicked under this light occluder to the node. This create point is clicked, and I'm just going to click there and just create point on the player node. So, and if there's a mistake, you can easily click on this erase point to erase the point. So I can just erase this if that's a mistake, and I can keep doing what I'm doing. Okay, there is no need for it to be perfect actually. I can just go over here. Since some parts will actually be covered in shadow, so I already see that they are not actually very symmetrical. Okay, all the points that you've added are actually inside this array, and there should be 26 currently. So that's if I'm right, and you can already see over here that this is actually not very symmetrical. So if I want to add the point, okay, if you made a mistake, you can just use Control Z to undo. For now, I think it's okay actually. So I'm not going to tweak the settings over here. So I think that's okay. Well, actually, you know what? Let's just leave it at this. So if you want to add another point as at your already created point, you can just click here, and when you drag, you saw this preview of where the points will be added. So you can just click and you can move around. You can move the new points around, or you can delete it. And now we're going to add another light occluder to the. Okay, we're still getting this here actually. Well, I've already said the occluder, so we can just ignore the one over here. Also, we are going to create another light occluder, but we also have to be very wise. The enemy and the player has the same shape, so I can just create this and just, if I like, I can copy and paste it, or I can save it as a branch scene. But if there is a lot of node that I wanted to add this light occluder to, I can just save it as another scene and just instantiate it, and so that the scene will be under the enemy and the player. But since we're just using it for two nodes, I can just click on this, copy, and over here I can just click on paste. And so now we already got the light occluder. We don't need to go over the process again, and let us test the game. Okay, now we are getting a very unwanted event. So, and this really has to do with our lighting. We've disabled the the directional light, which is very wrong. Also, our point light shouldn't add that level of intensity. So let's set it to maybe 0.7, and let's see what happens now. So when you're adding lighting effects to your game, it's all about tweaking the properties and see what works best for you. And okay, you can already see that this has some really cool effects to the game, and especially brings some light, some life to the game. Okay, actually, what we can also do is we can add like a lamp over here and just prevent the player from going there, because take a look at this. Just take a look at this. We don't want that in our game, so that and how are we going to do this? Well, we just add like maybe an area 2D over here and ensure that we are adding the lamp texture. So we can call this danger area, and I'm going to set the sprite to be equal to our previous created lamp over here, and we are going to add collision shape, and let's just quickly go over it. The collision shape should be circle, and you just resize this. And if you want to move this danger area node, and we don't want to move all his children or any of his children, we want to move the main parent, because don't forget, as we move the parent, the child moves relative to the parent. So now what we want to do is we want to click on this, so that when we move the parent, only the parent is actually moving. The children will move along with it, but we don't want the children to move separately, and this can cause a lot of issues, and we don't want that. So when I click on that, I can just drag the lights node around, and if you are looking at if you are uh, pondering where you are going to put the danger area, don't forget our position over here. So that has to be the width divided by 2 and the height divided by 2. And we just go to the project window. That's 640 times 320. So this has to be 320, and this has to be um this has to be, I think that should be 160. Yeah, I think it's centered now. So 640 divided by 2, that should be 320, and 320 divided by 2, yeah, I think that's it. Okay, I think that's cool actually. Okay, sorry. Except this has to be at the top actually. At the top. So now we can just set the area entered signal. And first of all, if it is player, what you're going to do is if it is yeah, player, what you're going to do is if it is player, we are going to reduce the health. And I'm actually thinking of a way to just push the player away from the light. So first of all, let's change the health. We're going to reduce it by, let's just say maybe 30, because lights are very 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 powerful, and they are very very dangerous in this game actually. So now what you can do is let's find a way to push the player away. We have this direction factor over here. Okay, I can just set the direction to equal to no, actually direction equal to factor 2, and we are going to have -1 1. We are going to pick it randomly for the x, and -1 1, we are going to pick it randomly for the y. Oh sorry, yeah, that should be area dot direction. And now let us test the game. Okay, actually it's not working. Why is it not working over here? Well, that's because of one thing. We have the speed, and if we are actually not if you are not pressing anything, you won't get any direction movement. So don't forget, we have this direction to equal to this input on this vector. So I'm thinking of there should actually be a way to just move it around. Actually, there is a lot of ways to go about that, but the first way that comes to my mind is to use yet another node, so that I can actually explain this node actually, and that's marker 2D. So what do we use marker 2D for? Let's first create a node for grouping. Let's call this markers. The reason why what we use this for is, okay, let's just change this to node 2D. It's because if you want like a point in 2D space, and we just want the point, so we can use the marker 2D node for that, and that's what we're doing here. So I'm going to add the marker 2D. I think that's it. So just put it here, and I'm going to press Ctrl D, duplicate and duplicate and duplicate. Okay. I'm going to rotate it. Okay, there's a duplicate marker 2D here. So there's also one over here, and we want to avoid duplicates as possible. We don't want it at all. So again, not rotation. Okay, I think that this is okay. Okay, I just assign this. Okay, we don't need to assign it to any group, since we can just go over it over here. So what we are going to do is we can just lap the position of the area. Let us set it to global position. So from global position, we are going to set it to markers dot get children dot pick random, if that works. And let's set it to 0.4. So now let us test the code if it's actually even working at all. Okay, it's not working. Okay, yeah, we're not just going to pick it randomly. We need this global position. Okay, let us go right again. Okay, it's working as we expected. This is really cool. And so that is all about the lighting part, and I really hope you've enjoyed this part of the tutorial. And if you do, please leave a comment and subscribe. I'll be dropping more tutorials very soon, and see then, stay safe, and I wish you good luck. Hello world and welcome back to the tutorial. And in this tutorial we'll be adding health to the player actually. So we add it as a pickup so that sometimes it just spawned randomly on the screen so that the player can pick it up. So that's what we are going to be adding in this tutorial actually, and we're going to be fixing some errors uh, in our game. So first of all, we need to create the earth image. We're going to make it 16 by 16, the width and height. Okay, and now we are going to start our drawing. This is just a very simple game, so there's no need to overcomplicate anything. So just place some pixels around, and you will generally have a heart shape. I like to make my pixel art like this, just roughing out the basic shape and just fixing those errors pixel by pixel. So that's what I'm going for over here. So there are other methods obviously, but I really like this. um, Now I can just make the basic adjustment to the shape. And if you like, you can add basic lighting, but I don't think there is any need for that in this particular game. So we have our art, and if you want, we can just make it so that it's a full art if you want. If you don't want that, you can just, there's no need to make it a full 16 by 16 art. So but that's what I'm going for over here. So I'll just export it, and very quickly. I believe I've explained the steps in pixel art in previous tutorial. So if you haven't watched that already, you can kindly do so now. So let's go back to our Godot editor. We are going to create a new scene, make the root area 2D, and we're going to name it Earth. And we are going to add a collision shape node. For a shape, first of all, let us drag the image to the sprite 2D. We need a sprite 2D. So we are going to drag the Earth image to this over to the sprite 2D, and under collision shape, we're going to make it a circle. And we just want to scale it down a bit. Okay, maybe take it up. Okay, I think this is a very good uh, a very good hitbox shape. You can also call the collision shape an hitbox shape. So now that we have the art scene, we are just going to save it as art.tsn. So, and under the signal, okay, first of all we need a script, not under scenes, under script. And now under the signal, you are going to click the node. Under the signal over here, we are going to connect the signal of area entered. And don't forget, as I've mentioned in previous tutorial, that's because our player is also an area 2D. So suppose that our player is not area 2D, but let's say it is uh it has a physics body. It's not just an area. We are going to be using the body entered signal over here, not area entered. So we're going to be using area entered because our player is an area 2D. So and now what you are going to do is we're going to check um if area is in group of player, and if it is, we are going to increase the score, no, the health, sorry, pardon me. We're going to increase it by, well, let's say 20. And now in the main scene, let's just test everything. We're going to just drag an art over here. Okay, it's working. You can already see that the art is increased, but we obviously need to delete the art when we get to it. So um but before that, I actually want to explain another node, and the name of the node is uh, animation player. So what we use this node for is we use it for creating animations in our games. And now the animation that actually we are going to be creating here is very simple. I don't even know what to call it. Let's just call it maybe wiggle. And we can set, we've already named our animation wiggle. If you want to create an animation, click on this animation button, and you're going to click on this new, and you're going to provide a name. But we are not going to do that because we've already created an animation. So you can set the length property over here. I'm going to set it to 0.4, and now let's go under the sprite. Now we can animate almost any node property, but obviously it has to make sense. The property that you want to edit it that you want to animate is property. So first of all, we're going to be animating the, I'm thinking of the rotation property. I think that will look better. -10, and just click on create. If you got this pop-up that says, do you want to create reset tracks, don't create and we're going to go to the mid, and obviously there's no even need for that. Let's go back over here. We're going to set it to 10, and we are going to click on this to create another keyframe. We've created one over here, and obviously we want to create another one. So now what is going to happen is we are going to get some animation between -10 for the value of rotation and 10. But now our animation is playing correctly, but there seems to be a little problem. It's just playing ons. So to loop it, you can click on this actually to loop it. But again, we are getting these the value moving from -10 to 10, and then to -10. But it is not easing to -10. It is just like it's not, there's no 20 going on over there, so the value just jumped from 10 to -10, and we are getting this little jaggy movement, which we don't actually want. And to actually fix that, we are going to change it from looping. We don't want it to loop to not just only looping, but I think it's called like ping ponging, so that it loops, it is left to right and also right to left, because for now it is only using left to right, it's not using right to left. So we are going to click on it again, and now we are going to have this little wiggle animation. If you like, you can also add as many animations to it as possible. For example, you can add the scale, the position, whatever you like. But this is actually a very simple tutorial, so I think that's okay. Also over here, whenever we reach the earth, we are going to delete it. First of all, let's disable the collision shape. I've explained this in the previous tutorial. And now we are going to create a twin. I'm going to set to parallel. If I haven't explained why we are calling this set parallel, is because we want to call all of our twin at the same time. Let's say we don't call this method the set parallel method. It's going to call them one by one, and it's going to execute it from top to bottom, and we don't want that. So now, first of all, let us twin this. I'm thinking of the scale of sprite 2D. And let's just scale it up 1.5, 1.5, and we're going to make it really short, and also we're going to fade it out. Same sprite 2D, and we are going to make it 0 and then 0.1, and now we are just going to remove the node because we don't need it anymore by calling the cookie free method. And now let us test. Let me pause this. Actually, we are going to get some errors if my calculations were correct. Okay, yeah, we're going to get this error, and that's because whenever you've created your animation, you need to set you can play it when the node enters the scene tree, but you can also auto play when the node enters the scene tree. So, and that's what this button is for. We also have it in the animated sprite, the node. We also have it over there, but, and I believe I've explained this button, so I just click on it, and now everything should work perfectly. Okay, I think that's cool actually. I think that is very very good. If you like, you can also add a light occluder 2D to the health. So now what you are going to do is we are going to be randomly generating the health. First of all, let's go to the timer. We need a new timer, health timer, and this timer is actually going to be a random timer. First of all, the wait time that we are going to set initially is 30 seconds. You want to enable this one shot and auto start property over there, and under the timeout, this is where we are going to be creating the art. So we need art to equal to the load. We're going to call the load function. We're going to load the art scene, and here we are going to be adding the art to the scene. And now we're going to set its position to equal to okay, actually don't forget a position is a vector too. Run the range. I'm not going to set it from 0 to whatever we want to set it. I'm going to set from 16. Don't forget we want to give it some initial offset over here, 16, and it's going to be the project width and obviously the project height, and that was 640 times 320. So this is 640. And now you probably spot the mistake. First of all, let's set this to global position, and also this is 640 minus 16, and that's also 320 minus 16. Obviously, if you are creating a larger project, it's more suited to create a variable for this value of 16, just in case you want to change it, because you can already see that we are just offsetting everything with 16. This is 0 plus 16, and this is 640 minus 16, and this is 0 plus 16, and this is 320 minus 16. So the 16 is actually a constant value, so you can just create a variable for it if you want, but this is a very simple tutorial. You don't need all of that. And so we're going to create another node. Let's call it art, and over here we are going to add the art that we created as the child of the art. Okay. Okay, I don't understand what is going on, but I think okay, this should work actually. I don't really understand what's going on, but it should work. I don't think there's any error in the code. Okay, that's really cool. Also, what we actually want to do is we don't want the art to stay there forever. So we want it so that let's say our player doesn't collect the art for some time. Obviously, we're just going to remove the art. So that's what we are going to do next. Okay. And let's go back to the art scene and let's create a node. Let's call it timers, and we're going to add a new timer, and you can set this wait time to I think 5 seconds, one shot. But again, there's really no need to set it from there. You can just go to the ready function and okay, that's not a good name. Let's call it lifetime. So I set its wait time to random value between 5 and 10 seconds. Okay, actually let's set it like this. Thinking of 4. Okay, maybe that's good. Okay, now I'm thinking about creating a dead function. You see why we create this dead function very soon. I'm going to copy everything from here and paste it over here. You want to ensure that the tabbing is correct. And now we're just going to call the dead function over here. And also over here, we're going to call the dead function. We don't want to be repeating to copy and pasting the same thing. So that's why we create this little function over here. And now everything should work as expected. Also, there is some weird behavior going with the enemy scene that we are going to fix next. Another thing about a game like this is we want to limit the player edge to some value, because right now let's say the art keeps popping and I just keep eating it. There's really no limit what my art can do. Okay, let's see if I can. Oh gosh, I missed that. Okay, this is not good. This is not good. Okay, why is no art popping anymore? I'm not seeing any art. Oh gosh. Oh yeah. That's an error. I've just recorded the error actually. And that's in the main scene, the art timer over here. And over here we need to create the art timer, and we're going to set this wait time to equal to random value. Okay, 5 to 10. Oh, that can be actually. So thinking of 30 to 60. I think that's okay. Okay, and before we actually test if everything is working perfectly, let's fix the enemy scene. Let's go back to the enemy scene and sorry, let's click on this script icon over here, and we're going to look for when the enemy died. What is going on when the enemy died? So okay, when the enemy died, we are setting a lot of things, but we are hiding a lot of things. But don't forget, we also need to hide the light occluder 2D. And I think this should fix the weird behavior that's going on. Okay, I think that has been fixed. Okay, I think the player bullet is moving a little bit slow. I think we fixed that. We also need to fix the health behavior. Okay, to fix the error, we are going to go to the player scene, and over here we are going to set if health is greater than 150. We are going to set the health to equal to 150. So I think that's it. Everything should work perfectly. So that's it for the tutorial, and in the next tutorial actually we're going to be rounding things up by talking about how to export our project. And that's it. I hope you found the video helpful. If you did, please leave a like and subscribe, and you can also support us by buying us a coffee or joining us on Patreon. Thank you and bye. Hello world, welcome back, and actually this is the end of the tutorial. But before we end everything, we're going to talk about something that is actually very very important, which is exporting. So we've created a game. How do we export it? Good question, actually. Very very good question. uh you can export it uh to Windows, Linux, Mac OS, and Android, and so on. But most importantly, you can export it for the web, so that you can get some file that's probably going to include uh, the HTML file, so that you can run in almost any browser. And if you are making an export in Godot, that's the most common export that you are going to need. But you are going to go over the export in general. Now we can see that we can oh okay, sorry. To get to the export dialog, uh, click on this project, and you're going to click on export over here, and you can see these platforms that we have Android, iOS, Linux, macOS, web, and desktop, Windows desktop. And before we go over them, let's go under the project setting, and we want to discuss some things over here. First of all, we have this configuration file. This is where you set the name of your game. Before you export it, you must set it to the correct name. You can set the icon over here. You can change the icon to your game icon. You can set the fashion and the description of your game. And also, when we run the game, what is the first thing that is going to run? So that is the main scene. So you can set the main scene over here. Obviously, in our game, we want it to be the menu scene. And also, we have this boot splash, and this boot splash is for when the game is loading. Obviously, when the game is loading, it's going to be showing some Godot, Godot. Okay, seriously, Godot is going to be showing some Godot image, and we don't want that. So you can set the custom image over here. and you can set to maybe show the Godot image or any image at all over here. But let's just leave it at that because this is a Godot tutorial and we are actually proud of Godot, and we want everyone to know that we create our game using the Godot engine. And some other things is the window. We are going to ensure that the viewport height and the viewport width are correct, and you can set the initial position for example, let's say you are exporting for Windows, and you can ensure that maybe the player can whoever is playing your game can resize it or not. I don't think this is going to work on Android or maybe iPhone, but let's say on Mac OS X or Linux or Windows, this is if you don't want them to be able to scale up or scale down your game, which is important in some case but not in ours. So you want to set the mode to canvas item, because I think I've go over this in the previous tutorial. If you don't, when whoever is playing your game scale up the window, they are not going everything in your game are not going to scale up or scale down accordingly, so which is not actually what you don't want that. So you can set the environment. This default clear color is if I'm right, I think this is, for example, let's say you are loading something and there is some maybe transition, or let's say there's no noise in your scene, and there's going to be a background. So I think that this default clear color over here. You can change it if you want, but I think that's all. We've talked about the texture. You can change the rendering over here. We are using compatibility, but let's say you want some other rendering, you can change it over here. And that's it for the project setting. Now let us go over the export. I'm going to talk about the web and the Windows actually, and this should hopefully give you a head start on how things actually work in Godot in general. Okay, first of all, let us go over the window. Okay, actually, I'm getting this error, and I'll tell you why I'm getting the error very soon. That's because when you are just exporting, you need to download uh, an export template. So right now there is a Godot 4.4.1 export template that I need to download, and this is where I'm going to download it, and it might take a while. So okay, I'm having a little bit of issues with downloading the export package. So I'm using this Godot version of this Godot 4.4, and I already have the export template. So whenever you saw any errors that is shown over here that you need to download something, just go ahead and download it. So if you are just getting into this export window, we have this preset. So this is where you are going to be choosing what platform you want to export to. So you can already see I've explained all of this. We have Android, iOS, Linux, Mac OS, web, and Windows desktop. Let's say you want to port to maybe consoles or PS. Yeah, they basically mean the same thing, but there are extra processes if you want to port your games to other platforms that are not displayed here. So right now we can let's say you want to export to Android, you can just click on Android. And seriously, if you are exporting to Android, there are a lot of errors that you are going to come across with. Most of my export is actually for the web or for the Windows, and this is the two that I'm going to go about. If you wanted to port to iOS, there are also some additional stuff that you need, like the App Store Team ID that you probably needed. And for now, I'll just click the web. This is uh, one of the major platform that you probably want to release your game. And over here we have this VRAM texture compression. You can choose whether you want this texture compression to be the VRAM is actually the video RAM, but there is a little bit technical details to it. But for most of the time, if you leave it as desktop, everything is going to be fine, and it can also work on some good Android devices since it's for the web. But if you want it specifically for the mobile, you can just click on for mobile over here. But for most of the time, I just put it on for desktop. And again, don't forget, if you saw any errors, to just download anything, or just click on it and just download it. Or or if the error is wanting you to enable something, you can just enable it. So for now, I'll just leave it on for desktop. Yeah, I think this is the air tag, if I'm right. I haven't checked it before, but if I'm right, this should be the head tag. And we have this export icon. You probably want to turn it on. And obviously that's it for the export web. We have these tabs like resources, patches, features, encryption, and script. But actually you can stay away from all of this, because if you don't know what you are changing, please and please do not change anything, so that when you export the game, you actually get what you want. So now I'm gonna just click on this export project, and I can export it. But again, when you are exporting, one of the best practice is to create a separate folder. I can call it web export if I like. I can call it some other things, any name that makes sense to you. And over here, I actually like to just rename my file to index.html, because I want to upload it to the web, and the web is going to be requiring me, my file to have this index.html. Now I can click on save, but before I hit on save, you want to disable this export with debug, and hit on save. And now we've successfully have our web export. We are going to test it on the web, but for now, I want to go over something quickly. If you've exported your game to the web, you should see this remote deploy available. And when you click on it, it's actually going to be running what you have for the web. Okay, and now we already saw that our game is successfully uh deployed to the web. Now we can actually export this to the web, and we are successfully going to get something that resembles this very very well. So now I can hit on play to test if everything is working, and yeah, everything is working perfectly. This is actually very 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 nice. Everything is working perfectly. I can shoot on enemies. Let me test. Yep. If you don't like the feel of the game, you can even add maybe change the bullet speed, or stuff like that. Okay, actually we haven't talked about this ice before, but we are not going to talk about it anymore. You can easily just make a little bit of research on how to use how to save data in Godot, so that you can add this ice cup feature. But now we've talked about the web export, and now we are going to talk about the second export that I used to use, which is the desktop export. If I'm going to export my game for the desktop platform, this export console wrapper, you can leave it at no, or you can leave it at debug only. But I actually just love debug and release, but it's just a matter of preferences. This PCK, actually, when you export your game, is going to be creating more than one exe file. There will be one exe file, and there will be some .pck file. But when you enable this embed pck, we are going to get just one file, which is our .exe file. And here you can enable the Windows uh, architecture. For example, I can have two versions of the game, one that work compatibly with 32-bit window, and the one that work compatibly with 64-bit windows. But I just love to leave it as 64-bit. I think this works for most of the desktop. And here you can provide application data to your app, like the icon, the console wrapper icon, the file version name, the product version, the company name, product name, the description, the copyright, and so on. You can actually provide over here. And just like the web exports, we have the resource, patches, and features, encryption, and scripts. But you can just leave all of this as it is. Now I can hit on export. Uh, since this is just a window export, there's no need to put it on a separate folder. And don't forget, if this is enabled, you have to disable it. So exit on save, and you can actually ignore this all this warning. Now if you go to our file, everything should work perfectly, but let's test it. Okay, here we are, and we already saw that we have this the defender and the defender console. But again, if you launch it through this, you're just going to get an additional console where all errors and warnings might be logged. But again, most of the time, this is what the people are going to be launching. And we already saw this. We have all the features that we have enabled, like they should be able to resize the window and so on. You should have this button, all the settings that we enabled in the application settings. And now it should work perfectly. And here it is. Okay, and that's it for the tutorial. I'm very very grateful you make it to this so far. What I actually want to do is to actually try to make a game like this on your own, and you can use this to create many different kind of games. You're going to be learning nodes that are used for some certain things in Godot as you work on more games and more games. So my advice for you is to actually start making a new game right now. It can be like this game, or it can be a game that that we've already talked about most of the nodes you're going to be using for most of your games, but we've not talked about a major some major nodes, because this is a beginner tutorial. So you can make very simple games right now. So go ahead and make them, and you'll be learning a lot from doing so. Thank you. I'm very grateful you made it so far, and I'll see you in some future tutorials, maybe. Yeah, future tutorials. Bye.